Hello, and welcome to Introduction to C Programming. My name is Wynne, and this channel is dedicated to teaching you the essential skills needed to become a highly paid IT professional. In Lesson 1, I'll give you a short introduction to the C programming language, and then also give you an idea of what kind of tools you need to build and to run your own C programs. In Lesson 2, I'll be showing you how to set up your own integrated development environment, and also we'll be running our first small C program. Then we'll move on to Lesson 3. This is where we'll get our first taste of basic computations in the C language. Computations are the roots of any programming language. Next, we'll move on to control flow, using conditional statements and loops to control the flow of our program. In Lesson 5, I'll introduce you guys to the concept of functions. Functions are awesome tools for organizing our code to make it succinct and to make it easy to reuse. In Lesson 6, we'll explore one of the core functions of C, one of the functions of C that sets it apart from the other languages. That's the use of pointers to manually manipulate memory on the machine level. In Lesson 7, we'll learn how to create our own complex data types using C structs. Finally, in Lesson 8, we'll go over the finer points of getting user input, displaying information to the user, and handling files in the C language. The C programming language has been in continuous use for almost half a century. It's the root of all the programming languages that are used modern day. Programmers have been generating code in C for nearly a half a century now. It's the root of most modern day programming language, including C++, Java, Python, and C#. C is a foundational language that will provide you with the tools for further exploration in computer science, software engineering, or embedded systems. Welcome to the Introduction to C Programming Language. I hope you guys enjoy the course. So let's jump right in and start with Lesson 1. In Lesson 1, we're going to give you a brief overview of the language, go over some of the language features, let you know why it's important to know C, and also go over some of the tools that you're going to be using in this course to develop your own programs. So what is C programming? C is a programming language, and programming languages provide software engineers with human-readable text that can be translated or compiled into machine-readable code. Machines only understand a binary language, which only has two characters, a 1 and a 0. If human programmers had to write code in that language, the process would take forever and would be highly error-prone. Languages like C abstract away the computer's language and allow programmers to write code in a language that's easy for us to understand. The C programming language was invented by Dennis Ritchie and Brian W. Kernighan at AT&T Bell Labs in 1978. The C programming language has been around for almost half a century, and in that time it's been used for many different things. It's been used to create other programming languages like Python and C++. It's used in embedded systems, IoT devices, appliances. It is used to create popular operating systems like Unix and Linux. Also, a lot of the technology that runs our televisions and our electronic devices is also written in C. C is everywhere, and learning it is foundational to your computer science education. So let's talk about some of the features of the C language. C is a minimalist language. It's small and succinct, which makes it easy to learn and perfect for beginners. C allows the creation of compound data types through the use of structs, which is perfect for representing database items, E-squared memory, and all kinds of different complex structures. C provides low-level access to machine hardware, which is a powerful and dangerous tool. C also compiles in native code, which makes it portable to many hardware platforms. So why learn C? I mean, there are a lot of other languages out there. Well, for one, there are a lot of computer science concepts that you can explore in C that can't be explored in other languages. C helps you have a firm grasp of basic computer science. C has also been around for a long time. It's been around for 50 years. There are a lot of veteran programmers out there ready to mentor new young programmers. And last but not least, C provides you with some amazing professional opportunities in a variety of fields like electrical engineering, embedded systems, and robotics. So, what do you need to write C programs? Well, you need three things: a text editor, a compiler, and a debugger. The text editor is what you'll use to type in and generate the source code. The compiler is the component that will generate the machine code and validate your source code. The debugger, well, that's another step altogether. Sometimes there are problems in our code that aren't readily apparent by reviewing the source. The debugger gives us a look under the hood to see what's going on at the machine level. We'll use that to troubleshoot issues that we run into along the way. So you might be thinking, that's a lot of software I'm going to need to get started. Well, not really. Recently, all of these software tools have been integrated into a single system called an IDE. There are several of these available. Visual Studio, Eclipse are some of the more popular ones. In the interest of keeping this course free and accessible to everyone, we're going to be using an IDE called CodeBlocks, which is free to download. In the next video, we'll go over downloading CodeBlocks, installing it on Windows and Linux systems, and getting our first program up and running. Look forward to that, guys. It's going to be a lot of fun. Let's move on to lesson 2. All right, guys, let's get started. In this lesson, we're going to download CodeBlocks, we're going to install it on Windows and Linux systems, and then we're going to run our first program. So to get you guys started running your first program, go ahead and open your web browser, and in your Google search, we're going to look for CodeBlocks, and you should see the link pop right up for you. Once you're at the CodeBlocks site, for Windows users, we're going to go ahead and go to Downloads. And we're going to select the binary release. Assuming that you have no other build tools installed, what you're going to want to do is you're going to want to select this MinGW setup. And go ahead and click the FOSS hub. And your download should begin. Now for Linux users, you have a couple different options here. You can go and you can download the Linux build from the website, or you can use the sudo command, which we'll put at the bottom of the screen for you. So you can just go in, Control-Alt-T, and then sudo apt-get install, and I believe it's CodeBlocks, but I'll display that at the bottom of the screen. So here we have our CodeBlocks distribution for Windows. We can just go ahead and double click that. And we'll see our CodeBlocks setup. Go ahead and click Next. And this is just a standard Microsoft installer. So you can click through the menus like you normally would. You want to make sure that you do have MinGW compiler suite installing, because that's going to be our compiler, that's going to be our build tools. And without that, we're not going to be able to complete our task. And the default location should be fine. And in my case, the target directory already exists because I already have this software installed. You guys can go ahead and proceed with the installation. Should be normal fare. And we'll move on to loading up CodeBlocks and starting our first project. All right, guys. So I did want to show you guys one more thing, and that's onlinegdb.com. Anybody who has some reason why they can't install the software, or if you had any problem installing CodeBlocks, you can go to onlinegdb.com and still follow along with these lessons. This is a fairly simple little IDE that you can use. For those of us that do have CodeBlocks, go ahead and search CodeBlocks in your toolbar. I have mine right here. And I'll just drag it over to this screen. You're going to want to go ahead and create a new project. We're going to select console application. Go ahead and select next. This IDE does C++ and C projects. We want to go ahead and build a C project. Project title, we'll just call it Hello World. All these options can remain the same. So what the IDE will do for us is it'll create a workspace, and within that workspace, it'll create our project. And within that, it'll generate our main C source file. Every C program has a starting execution point. That starting execution point is main. Main is the function that will begin to run as soon as we click this run button. This program is a fairly simple one. You can probably look at it and kind of get an idea of what it actually does, right? We have a printf command. So this is a console program. And any of you who are familiar with Linux, even Windows command line, are familiar with what a console is. This printf command is going to print the string that we've designated here, or that's been designated for us, to the console. This is a classic first program for programmers. This builds it for you. And we can go ahead and click run. You'll get a message that says that the project has not been built. Do we want to build it now? Yes, we do. And in the resulting console window, you should see our text here, Hello World. It's a fairly simplistic program. Really what this does, what Hello World is for, people use it to test your build tools when you install a new IDE. It's just a simple program that allows you to make sure that everything is working. So if you got to this point, guys, we'll be moving on to lesson 3. We're going to start learning about variables and data types, operations, and operands in C. And we're going to use all of those to form powerful expressions that allow us to do a lot of work and automate a lot of tasks. Okay, guys, as we discussed in lesson 3, we're going to be learning basic expressions, data types, variables, operators, operations. Go ahead and get your code blocks open, start a new console application, and we will get started. All right, hello guys. We find ourselves back in our code blocks IDE here, and we can go ahead and create a new project. This should be probably familiar to you. Go ahead and select console application. We're going to make sure to select a C application, not a C++ application. C++ is a superset of C, but it's a much more complex language. For the project title, you can put whatever you want. It's kind of arbitrary. I'm going to put lesson 3. All of these options can remain the same. And you can go ahead and expand your source files folder, and we'll go into main C, and we'll see our familiar Hello World program. So here we are back at our familiar Hello World program, and we're looking at int main, which we know is the beginning of our set of instructions that we're going to be sending to the computer. And this program is just going to print the word Hello World and print a new line. And then it's going to return 0 to the operating system to let the operating system know that this program has run successfully. Programs like this are simple, but they're not very versatile, right? What if we had a more complex message that we wanted to send to the console? What if we wanted this, instead of saying hello world, to say hello John? And what if we had more information that we wanted to say about John? What if we wanted to let everyone know that John likes chili burgers? And then we had a new line. Okay? And we always want to end every line with a semicolon. That lets the compiler know that that's the end of that instruction. Let's say we wanted to let them know more about John. John eats chili burgers for lunch. Okay? And then another new line. And then one more statement. Let's let them know something else about John. John ate 3 chili burgers for lunch. Okay? And let's say we had one more piece of information about John. Let's see. Printf. John can't eat more than 3 chili burgers. Okay. So that's a pretty simple example, right? We're going to have more information that we're going to display here. We can go ahead and run and build that and see kind of what it looks like on our screen. Very simple, right? Hello, John. John likes chili burgers. John eats chili burgers for lunch. John ate 3 chili burgers for lunch. John can't eat more than 3 chili burgers. Very simple program. What happens, though, if we've written a whole novel about John? We've now got hundreds of lines of text about John and his adventures with these chili burgers. And anyone who's ever eaten too many chili burgers knows that it can be an adventure. But let's say that we got that wrong. Let's say someone comes to it and says, "Oh, I'm sorry, it wasn't John who liked the chili burgers. It was actually Joan, or James, or Billy, or someone with a different name." This poses a huge problem if we've written thousands of lines of code. We would have to go through and change every instance of John to another name. Let's say, for instance, in an even more simple example, let's say that on Friday, John eats more than 3 chili burgers for lunch. Let's say John now eats 4 chili burgers for lunch. Now we've got a real problem on our hands, don't we? Because we've got all these places where we've referenced that John ate 3 chili burgers. And we've also referenced that he can only eat 3 chili burgers. Now our program actually is incorrect. So we have a couple of options here, right? I mean, we could simply go through and just change all the instances of 3 to 4. That would be one solution to the problem. But if we had thousands of lines of code referencing the number of chili burgers John had eaten, or if his name wasn't even in fact John, we'd have a big problem on our hands. Well, that's kind of where variables come in, right? What a variable does is it allows us to save a place in memory where we can store a value, and we can reference that value anytime we want using that variable name. The process for creating a variable in C is that we have to first tell the compiler what type of data we're going to store. And the reason we have to do that is because the compiler has to know how much memory to set aside. So in this instance, we're dealing with the number 3. 3 is an integer. And that is one of the data types available to us in C. So we're going to go ahead and add that int. And that's going to let the compiler know, please give us the space associated with an int in memory. So the second part of this is, well, how do we want to reference our int? If we have an int, how do we set it apart from any other ints we might create in this program? Well, the one way is to give it what's known as an L value, which is simply a human readable name for a variable. And what we want to do is we want to try to make the variable as descriptive as possible. We want to try to make it so that when I read the variable name, I know exactly what that data is used for. It's not just an integer, is it? It isn't. It's the number of chili burgers, excuse me. So let's go ahead and do that. We're going to type that this is the number of chili burgers. You can use variable names that are more succinct, or you can use ones that are more verbose. I prefer verbose variable names that make it very clear what the variable represents. So now we have told the compiler, hey, give me this amount of space in memory. I need to store an integer. And we've also told the compiler, whenever I use the name, number of chili burgers, give me what you've stored in memory in that space. And what we can also do in this line is we can end it with the semicolon to let the compiler know that that's a statement. In our next line here, we can again reference this value, number of chili burgers. And we can go in now and use the equal sign. And we can tell it, okay, we have this space in memory. We're going to reference it with the number of chili burgers and place this value of 5 or 6 or 7 or 8 or 9 or 10 or any integer that you decide is appropriate. We're going to place that value in that space. And whenever I reference number of chili burgers, I want you to give me that value that's stored in that location. The beauty of that is it allows us to set the number of chili burgers at the beginning of the program and change it anywhere in the program we want. As far as using the printf statement, we have another tool at our disposal. What we're going to do is we're going to use, we talked about the escape characters earlier, where we can actually issue commands like here, where we've issued a new line using a /n. It doesn't print /n, it just prints a new line. That's a command. We also have substitution strings. So what we're going to do is we're going to replace 3 with %i. And %i tells the compiler that when you print this line, we're going to print an integer in this position. We're going to go to the end of the line, we're going to add a comma, and now we're going to specify to the compiler which integer we want to use. And in this case, it's the number of chili burgers. And we'll go down to the line below and we'll tell it the number of chili burgers. Very simple, right? We are now going to replace the literal 3 with a variable that tells the compiler to replace that integer stored in that position with the variable of our choosing. Okay, and we can go ahead and use the run and build icon with the gear and the play symbol. And we should be able to see now that John ate 5 chili burgers for lunch. John can't eat more than 5 chili burgers. So we can see how this substitution principle works, right? We tell it not what specifically we want printed here, but what we do tell it is what type of data we want to print here. And then we can specify that data after a comma. The beauty of this is if it changes and tomorrow John eats 7 chili burgers, well, that's simple enough, right? We just change this value to 7. We build and run. And now we can see in both places, it substitutes that value. If this had been 1,000 lines of code written into this story, and we kept referencing this number of chili burgers over and over again, this would make things much simpler for us. So in C, there are also other data types, right? We couldn't get by in programs without having other ways to express ourselves. We can express numbers as integers. We can also express numbers as floats. So a float is actually the same way that int is an abbreviation of integer. Float is an abbreviation of floating point number. What is a floating point number? Well, a floating point number is a number with a decimal. So we'll just call this exact number of chili burgers. So let's say in this instance, John comes in the next day and he's really trying to push himself. This time, John's going for the record. He's not going to settle for 7 chili burgers. That's for lightweights. So John gets through the 7th burger, and he gets 3/4 of the way through an 8th burger, but does not finish the 8th burger. In order to keep John accountable and to keep John honest, we are now going to replace our integer with a floating number value, right? We're not going to give him credit for 8 burgers. We're going to give him credit for 7.75 chili burgers. Now, what we need to do is we need to go down to line 13, because on line 13 it's expecting an integer, but we're no longer using an integer. We're using a float. We have to tell the compiler, let us print a floating point number. And we also have to tell our compiler that we're using a different variable in this place now. Okay? And go ahead and play. Oh, wait 1 second here. We've got an error if you followed me exactly. And what happened here is I forgot to end my statement with a semicolon. So this is another example of how the compiler keeps us honest and makes sure that we don't have errors that get through in our programs. And now we can see that John ate 7.75 chili burgers for lunch, and John can't eat more than 7.75 chili burgers. Quite simple. Quite simple. And there are additional formatting instructions that we'll go over later on that will allow you to format those values more precisely. But for now, it's just enough to know that we're capable of creating variables. We're capable of creating variables of different types. And we're capable of substituting those variables in our print statements. Let's say we got this really wrong. And let's say John isn't the man we thought he was. Let's say John is actually a guy named Bill. What are we going to do now? Well, the values that we can store in C are not just number values. We can also store characters and strings of characters. And to do that, we let the compiler know that we want to store a car, which is short for character. And we'll go ahead and call our car name. Now, that's all fine and good if we want to store one character, A, B, C, D, E, F, G. If we want to store a string of characters, we have to let the compiler know exactly how many characters we want to store in memory. And to do that, we'll use brackets, and we'll enter the number of characters we want to store. Okay? One thing we did with our float is that if you notice, when we told the compiler to set out the space for our float, we told it how we wanted to reference our float, and we told it what value we wanted to put in that memory space, all in one sentence. All in one statement, rather. And we're going to do the same thing with name. We're going to tell it, hey, we want a character, a string of characters. We want to call it name, and we want 10 characters there. And we'll go here and we'll put in Billy. Okay? Just, you can use whatever name you want. Just make sure you don't exceed the number of characters that you've stated on the left-hand side of the equal sign. Now what we're going to do is we're going to go through this code, and wherever we put the name John, we're going to replace it, and we're going to let the compiler know we're just going to be printing a string here. We're just going to be printing a string of characters, and we want to print the string of characters associated with the value name. Go in and replace that everywhere we can. Now, this is a little more interesting case, isn't it? As we get down to line 14, notice we have 2 substitutions, and they're substitutions of different types. So we're going to start with the substitution of the string for the person's name, and then we're going to move to a float which is going to be the exact number of chili burgers. What we want to do is we want to put these in sequentially. So it's going to be name, comma, exact number of chili burgers. Name, comma, exact number of chili burgers. And then this is the final substitution with S. I think we've got everything correct here, but the compiler will let us know if we've made any mistakes. And we haven't. So we can see here our end message. Hello, Billy. Billy likes chili burgers. Billy eats chili burgers for lunch. Billy ate 7.75 chili burgers for lunch. Billy can't eat more than 7.75 chili burgers. And we could go on into a deeper example where Billy considers that to be a challenge, and maybe now he comes back and now it's 10.75 chili burgers. But I think you guys get the general idea of how variables are used and how substitutions are used in strings. And that's a very powerful tool in programming, to be able to substitute values in and out and be able to have things that build themselves dynamically. That's going to be a strong tool in your tool belt as you go forward in these lessons. So I would take a little bit of time, maybe pause the video now, maybe kind of tinker and toy around with that. What can you do with different names or different values? What kind of different stories can you tell? Just using this printf function. So the first thing we want to do here is let's go ahead and get rid of our existing program and start something new. Let's go ahead and say we're going to have a program where the first thing we're going to do is we're going to get the user's name. Because in the prior program, sure, the string substitution was easy enough, but every time we had a new user name, we would have to go into our source code and update that information manually. Let's go ahead and change things so that we can get that information directly from the user. Okay, and we'll add a printf statement to introduce the user to the program. Welcome to the program. That. And then we will say, what is your name? Okay. And that's simple enough, right? This is really back to the hello world stage, right? This is just printing literal strings to the screen and allowing the user to view them. Well, printf is great for output, but there's also a similar function called scanf. And what scanf does is it allows us to get input from the console. And the syntax of it works very similar to printf. So some of you might be able to look at this point and kind of guess what we need to do here, right? With printf, when we use substitutions, we use the % and a character to let the compiler know what type of substitution it was. And then we gave it a variable name at the end to let it know which reference we wanted it to pull the data from. Well, for scanf, what we do is we let it know what kind of data we want to receive from the console, and then we let it know where we want to store that data. Okay? And then we can go back to printf, and we can say, hello, and then name. Okay? So this program is going to give the user some instructions. We're going to wait for the user to respond to us, and then we're going to greet the user. And let's just go ahead and add an exclamation point on the end here. Let the user know we're excited to have them using our program. Go ahead and build. And we can see here it asks us for our name. Make sure not to use a name with more than 10 characters. Or just go back into your source code and extend the number of characters that you can use. But we'll just say it's John. And we can see that it displays hello John, as we'd expect. Okay, so now we see kind of how the input-output flow works, right? But what else can we do with that? I mean, who would want a program where they tell us their name and then we just say hello? Users want to be able to give us valuable information and to have us perform calculations and manipulate that information algorithmically to give them back something of use. Sometimes your user isn't even a human being. Sometimes your user um, is another program that's sending you data, and you're going to perform and service that data and send it back to that program or send the data off to another program. So let's just say in this program, we're going to calculate the number of chili burgers eaten by the user. And we're going to kind of change the convention for variable naming. Instead of using the number of, what we're going to do is we're going to specify our variable type with a letter. So if it's an int, we're going to proceed with I. If it's a character, we're going to proceed with C. And we can go down and make our change here. This isn't very useful right now, but as your programs get longer and start to expand and take up multiple files, it's very useful to be able to instantly identify the type of variable you're working with. So we're going to say int, and this is chili dogs. And we're going to say int, and this is chili fries. Okay. So the first thing we can do is come down here, and after we welcome them to the program, we can say printf, substitute a string, how many chili dogs did you eat for lunch? Okay. Oh, wait a second. That's not the right variable. Name. And then for this one, I'm just going to copy and paste how many chili fries did you eat for lunch? Okay. Now, after we ask them how many chili dogs they ate for lunch, we're going to want to scan the console and see what their response was. This time we're going to expect them not to respond with a string of characters, but with an integer. And we're going to store that integer in chili dogs. And we're going to store this integer in chili fries. Okay. And now we're going to return to them some piece of data. Eight chili dogs. Substitute integer. Chili fries. Now we're going to print a new line. And this is another interesting thing here. You don't have to always use a new printf command to get to the next part of your statement. If you already know the total of what you want to say, we can actually use this escape in, and this will print a new line. And we'll be able to say string 8 items. Okay. Now, what we want to do here, there's a couple different ways we can approach this. What we want to do is we want to get the user's input. We want to find out how many chili dogs they ate, how many chili fries did you eat, and now we're going to do a calculation that tells you the total number of items you ate for lunch. We can handle it a couple of different ways, and we'll kind of look into different ways of handling it as we go through the tutorial. The simplest way is to go up here and take I, total items, equals 0. Now, what we basically have created is we've created three relevant operands, right? Chili dogs, chili fries, and total items are all operands. We want to perform an operation on these operands to get the sum. Total items equals I chili dogs plus I chili fries. Okay? Simple enough, right? We're going to get the total number of items, and then we'll be able to print that down here at the bottom of the screen. And this is where programming in C can get a little complicated, as you have to keep your eye on the order of your operations. So the first one we have is a string substitution. That's going to be the person's name. And this is just a formatting thing where I keep adding the spaces. It just makes it look a little cleaner and makes it a little easier to keep track of. The second thing we want to see is the number of chili dogs. The third one is going to be the number of chili fries. And then on the next line, we want to print the number of total items. So here we have our program, and one thing that I've neglected to do, whenever we reference a variable to the program, we're actually referencing its value. And we'll get a little more into this when we get into pointers and really the underlying mechanisms with how all these memory operations work. The only thing you need to know now is that before putting this variable here, we need to put an ampersand. And the reason we need to put the ampersand here is because scanf does not want to get the value of I chili dogs. It doesn't want the value stored at that location. It wants the memory address where this value needs to be stored. I know that's a little complicated, but for now, all you really need to know is that when you are scanning and you're looking to put the value of an integer, you have to use that ampersand. Okay, so some of you are probably naturally wondering right now, why do I need an ampersand prior to I chili dogs and chili fries, but I don't need an ampersand prior to CNAME? Don't worry about that right now. We'll definitely get into that as we get into memory manipulation and some of the more difficult points of C. Just for now, just know that this is an array. It's 10 characters in memory. This is just one integer in memory. And that's the reasoning behind it. It'll make more sense as we go on. And one other just quick thing I noticed about our substitution here is that we do need an additional C name because we're printing that name twice. So let's go ahead and build and run our program. And enter a name. And we'll say that John had 20 chili dogs for lunch. And that he had 15 chili fries. And we can see that John ate 20 chili dogs and 15 chili fries. John ate 35 items. So that is our basic programming loop, guys. We want to receive some kind of input, okay? Which is essentially this part of code here is all about receiving input. We want to perform some kind of process. This obviously a very simplistic process. It's a one-step algorithm that gets the sum of two values. And then we want to return something useful to the user. And in this case, it's just going to be a console message that lets the user know what the total items are. All right, so that pretty much goes over that whole stream, right, guys? We can see here how we use our data types to reserve space in memory. We can see how we use our variables to reference space in memory. We can see how we get input from the user, how we display information to the user. We can also see how we use our variables as operands and how we can use operators on our variables to form expressions that alter data. And that's pretty much what programming is. It's really just more complex versions of that same process. And we'll be adding some tools to your tool belt as we go, kind of hour after hour. And, these operations, guys, it's not just limited to addition, right? We have different symbols that we can use. We have a multiplication operator, which is the asterisk. And we have a division operator, which is the slash. And we have a minus operator, which is the minus symbol, right? So any of these is a valid arithmetic operation in C. So we could easily say that, I total items, chili dogs, minus chili fries. You ate blank chili dogs. You ate blank more chili dogs, right? We could change that around and go ahead and run and execute the program. Oh, 1 second. And we'll ask our name again, John. Had 10 chili dogs for lunch, 2 chili fries, and we can see that John ate 8 more chili dogs, right? So we can do any kind of arithmetic operation that we want. It's not just limited to sums or addition, and there's different math libraries that allow you to get deeper into that as you get deeper into your C career. As we move on to the next step here, we're going to be getting into, well, how do I control these programs, right? It's nice to have this kind of flat sequential structure where the program just executes instruction after instruction. But what if we want to do some things in certain cases and other things in other cases? What if we want to ask the user, did you even eat lunch today? And if they didn't eat lunch today, well, why do we even need to ask them how many chili dogs they had? We already know the answer is 0. So the next thing we're going to get into is control flow and how we control the flow of our programs. We're going to get into a few kind of gamey kind of examples. I always think those are fun, and it's a good way to kind of introduce people to the logical constructs that we build using our control flow. So we'll be jumping into lesson 4 next, guys. Operators, to evaluate the state of variables against a certain condition. And we'll get more into that here as we begin. Everything else in the control flow relies on these conditions, right? Our ability to compare the state or the value of 2 different entities. As we get into while loops and into for loops, what you'll see there is those loops are going to allow us to perform a specific action or to execute a specific operation or expression as long as a certain condition is met. These are powerful tools in programming, and you're going to use these literally in every program you write, more than likely going forward. So pay specific attention to these control flows. This is really starting to get in outside of just that input, process, output. This is the root of that process step right here, is tied into control flow in these conditional statements. Okay, so here we are in lesson 4, guys. And you can see I've created a separate project for lesson 4. You can create a second project, or you can just clear out your text editor from the prior lesson. And while you're doing that, I'm just going to go over here, just really quickly, talk to you about comments. Commenting your code. Comments are these lines you see that appear in gray here. There are 2 different styles of comments, those kind of inline comments, and then you can put comments in a block style, where you can put as many lines in the comment as you want. Comments are extremely useful, particularly for programmers when they're starting out. What I used to like to do when I was working my way through my college courses and when I was a beginning programmer, just starting to really, write out, my algorithms, was to go through and to make sure I had my head around the whole of the problem. And the way I did that was the same way I've done it here, by just writing comments. In this particular lesson, what we're going to do is we're going to go over comparison operators, if then statements, and basically the whole control flow aspect of programming. In this first little segment, what we're going to do is we're going to declare two integers for comparison, and we're going to get the user input for those values. Okay? And I just kind of wrote that out step by step, just so I make sure that I know exactly what I'm doing before I start doing it. And the first two steps here, even the last step really, you guys should be able to do based on what you've already learned. And if you want to try to pause the video and just try to fill in as much of this as you can, I would recommend that you do it. I mean, the worst thing that can happen is that it doesn't work, and then you get a reinforcement of a prior lesson. I would pause the video and try it now if you feel so inclined. If not, you can go ahead and follow along with me here. First, we're going to declare two integers. We know how to do that, right? We say int, which specifies to the compiler that we need memory of a certain size. I'm going to precede it with I because it's an integer, and then I'll just call it num because it really doesn't represent anything. It's just something we're going to use to compare. And because we're going to have multiples of them, I'm going to use 1 to specify this one. And we're going to do it inum2. So now we've declared two integers for comparison. Next, we're going to get the input values from the user. We'll just ask our user to enter number 1. And we'll use scanf if you remember. And we'll tell the program, the computer, that we're expecting an integer. And we'll place that integer in inum1. And we will also add our ampersand to send to scanf the address associated with inum1. And then we'll ask for number 2. You can copy and paste that first one if you want to, and just make the changes. And then we'll ask for a second integer here. That's going to be inum2. And that part you should have been able to do pretty much on your own. And then we'll just give a confirmation. You have entered. And okay. So this isn't anything we haven't done before, right? We're going to get a user input. We're going to display that input back to the user. One good habit to get into before you get into test-driven methodologies and all these other buzzwords in the software industry is to get in the habit of writing your program a little bit at a time. The last thing you want to do is to get 100, 200 lines in this text editor and then go to run the program and have it crash and have to go back through those 200 lines and try to troubleshoot a problem, when if you just test it little by little, there's very little to go back and examine when you do have a problem. So I would recommend you go ahead and build. Make sure you do get, process terminated status 0, which is successful. And then go ahead and run. Enter number 1, enter number 2. Just make sure the program works up until now, and then as we go forward, you never have to go back and check this part of the program again. We know that this works. We can be confident in that. So now we're going to go in here and we're going to compare two integers. Well, how do we do that? Well, the way we do that is we use some of C's built-in functionality. And the first built-in component that C has for comparing integers and any entities in the C language is if. If and then parentheses. And following the parenthesis, we're going to type in French brackets with shift, and then it's the key to the right of P. And what this structure does is if tells the compiler that we're going to want to evaluate the statement within the parentheses. And if that statement is true, we're going to run this code block. Whatever we put inside of this block is going to execute if the statement inside of here is true. Okay, so how do we write a comparison statement? How do we compare the value of num1 and num2? Well, that's simple. We can type I num1, 2 equal signs, and I num2. When you put those two equal signs together, that is a different operator than the assignment operator that we've been using up until this point. This operator is a comparison operator. And what the comparison operator does is it tells it to compare those two values, and if they're the same value, we're going to run this block of code. There's an accompanying keyword that can only be used with if, and that is else. Else doesn't require the parenthesis or a condition. It just means if this isn't true, we want to do this. Okay. In C, you can have an if statement without an else statement. You do not have to have an else, but you cannot have an else unless you have an if to evaluate. So right here we can pretty simply just print the numbers are equal. You want to get in the habit of this too, kind of just copying and pasting and not doing so much typing. Control V, and then here we can say that the numbers are not equal, right? You can get rid of that. That's actually should have been contained in this block, but that block wasn't there yet when we started. So, and we can go ahead and build this. Enter the first number, we'll enter 10, and then we'll enter 20. And we can see that you have entered 10 and 20. The numbers are not equal, and that is correct. And the computer will always get that correct. Computers are very good at computations. That's why they're called computers. And then we can go back and run it again just for be thorough testers. And if we enter 2 10s, we'll see that the numbers are equal. I did add a new line character here just for formatting purposes. So what else can we do? What else can we do? How else can we compare integers? How else can we control the flow of a program? Well, we can also say, is it greater than? Is num1 greater than num2? We could say if num1 is greater than or equal to num2. Okay? Which would effectively change these statements, right? We would say if this is 2t eq, well, no, we couldn't do that exactly. You know, and that would change this statement to num1 is greater than or equal num2. And then this one would change to num2 less than num1. Right? There's also other ways we could compare them. We could say, we could invert our original statement and say num1 is not equal to num2. So there are all kinds of operators that you can use for comparison. We can even do like bitwise comparison, which I won't go into in this class because you do have to understand a bit about binary and different computer sciencey kind of constructs. So I won't get too into how the bitwise operations work, but that's the basics of how we write a comparison statement. Okay. Now we can also add to that, right? Let's say we want to know more. We want to be more specific. We can actually add an else if. And this is an accompanying statement. It has to have an if. If you have an else if, you do not have to have an else. The else is never required. But if I want to know specifically if num1 is greater than num2, I can have a condition that allowed me to express that as well. And you can do any number of these, and they do not have to be related to the same sets of variables. Okay. And this one would actually still remain less than, right? If they're not greater than and they're not equal, then the only other conclusion is that num2 would be less than num1. But you can go ahead and test this and just make sure you type in a num1 that is more than the num2, right? 20 and 5. And num1 is greater than num2. So that's how we make comparisons. And we can make all kinds of different comparisons in the C language. Arithmetic comparisons, we can check to see if things are in memory. But this is the basics of it. And this is the basics of what you're going to be doing when you do comparisons. Okay, so what other kind of structures can we use to make comparisons with? Well, there are a couple of other ones. One of them is the switch statement. So what we want to do now is we're going to go ahead and declare a variable of type car. And this is going to hold a single character, not a string of characters like we did before. Get user entry for the car. Then the next thing we're going to do is we're going to evaluate the value of the car using a switch. So declaring a car is simple enough. Car C. And notice here we're not using the double quotes. We're going to have to use single quotes for a single character. We're going to get the user entry for the car. And we don't have to go through and alert the user. We kind of know that we're just doing this for a test. So we can just go straight to the scan C. Then we're going to want to evaluate that value. And the way we're going to do that is we're going to do a switch C. And within a switch statement, what we can do now is we can evaluate the value of the car. So this is the switch. This tells it what variable we're going to be evaluating. And then you could basically list all the potential values for that variable. And at the end, instead of an else statement, we're going to say default, that if none of the previous conditions are true, we're going to print this and we're going to say invalid entry. Right? We're just going to say it's invalid entry. It's not any of the things we were expecting. And then we're going to use another keyword called break. And that's simple. So what the switch statement is going to do is it's going to take C and it's going to go through each one of these. And it's going to say, okay, is C equivalent to A? Is C equivalent to B? Is C equivalent to C? And if it isn't equivalent to any of those, we're going to go to our default statement and execute it. So we'll just go here. We'll say printf user option A. And you might as well just kind of copy this on down. C. Now, if you notice at the bottom of default, there's another keyword there called break. And at the end of each one of these cases, you're going to have to use the break keyword. And all the break keyword does is it says, once you evaluate this case and you run this associated code block, break out of the switch statement and move on. If you don't do that, then when A is true, the code will actually fall through and continue to run until it gets to a break statement. Okay, and let's go ahead and try to build. Oh, I'm sorry. This should just be car C and then a semicolon, guys. And we should be able to go ahead and run this. And go ahead and make sure you're using the user for input. So we can go ahead and print F and just tell our user to enter A, B, or C. Okay. And that's simple enough. So we should be able to run this program now. We should get our user prompt. And we should be able to enter the letter of our choice. And we can see that the user option B was selected. If we go ahead and run this again, and I just want to show you kind of what happens, enter anything, enter 5. And we can see that we get an invalid entry if we enter anything besides capital A, capital B, or capital C. And the reason that is because if none of these cases are true, what the program does is it executes this default. And generally, this default is going to be used to handle an error case or an invalid input case. Okay, so the one thing we're going to need to make this program work, guys, is when we're getting a character that isn't a character array, when we're getting a single value, we have to, of course, add our ampersand so that scanf knows where we're placing that value. And once that part of it is done, we can go ahead and hit play or run. We didn't give it any prompt for the user in this situation. So we can just go ahead and enter our character, and in my case, I'll enter C. And we can see that user option C was selected. So now we're at a good point, right? We've got kind of the beginnings of what a basic program is, right? We can display information to the user. We can receive information from the user. And then we can respond to that information from the user in different ways. These switch statements can be used to take any kind of input, right? We could have an application that relies on a touch screen. And if the user touches a certain button on the screen, maybe we execute the first case. If he touches another button on the screen, we execute this case. A different button may execute this case. It's not always going to be, I don't want you to get into the mindset where this is all just for console applications. These are the tools that they use to build the programs that you run every day. So that's the switch statement. It's another way of it's a neater, cleaner way of doing an if else, but it has the limitation that you can only evaluate the condition of one piece of data. And so from here, we're going to move on to the next thing. And this is really key to programming and to algorithm development, is the existence of loops. So we're going to move in. You can go ahead and clear your screen, and we'll move into for loops first. All right, guys. And one thing we did forget to do, we forgot to put our ampersand before C. Whenever we're using scanf, we want to make sure we give it a reference or the address of the variable, not the variable itself. And I did add just here to prompt the user for input. So we can go ahead and print F and just tell our user to enter A, B, or C. Okay. And that's simple enough. So we should be able to run this program now. We should get our user prompt. And we should be able to enter the letter of our choice. And we can see that the user option B was selected. If we go ahead and run this again, and I just want to show you kind of what happens, enter anything, enter 5. And we can see that we get an invalid entry if we enter anything besides capital A, capital B, or capital C. And the reason that is because if none of these cases are true, what the program does is it executes this default. And generally, this default is going to be used to handle an error case or an invalid input case. So our switch statements and our if else statements are powerful tools in our toolbox, guys. Right now, what we have is we kind of have the ability to display information to the user. We have the ability to get input from the user. And now we have the ability to execute different blocks of code based on the user's response. And that's really what programming is. That's really what you're going to be doing for most of your computer programming career. These are just very succinct, small examples. Larger programs are just larger examples of these same core components. But what else do we need? What are the other core components of the programs that we use every day? Because if you've ever noticed, what you do when you use a program, it never goes to that exit point until you tell it to exit. And that's because most programs actually run in a loop. So let's say we want a program that doesn't just grab a piece of data, perform some set of steps and end. Let's say we want to get multiple pieces of data from the user. Well, we could always just repeat that process over and over again, right? We could just type out however many times we needed to the information on the screen, right? We could go through and just kind of collect this, right? And we could just repeat this over and over again going down the screen. But that's not a very good way of doing things, right? We end up with these huge text files that become incoherent, and we're duplicating a lot of effort by typing the same instructions over and over again. So the way we resolve that problem is we use loops. We simply tell the compiler that we want the computer to run this section of code a certain number of times. And the beauty of loops is instead of typing the same piece of code 20 times and then finding out, oh, we only need to run it 15, and then going back and deleting 5 instances, then changing it, what happens if the user wants to dictate how many times the program should be run? How do we do that if we're going to manually type in this set number? Well, one way we can go about doing that is by using loops. The best way to go about doing that is using loops. And there's one thing I want to explain to you before we get into loops and how they work. And that is preprocessor directives. A preprocessor directive, if you look up top here, is a command that starts with this hashtag or pound symbol. And what this does is it tells the compiler that we want you to perform certain instructions before you turn this source code into machine instructions. In this case, we're telling the computer that there are some other code that's pre-built in C, that's pre-written in C that we want to add. And that's what's providing us with some of these functions that we're using, right? That's what's providing us with printf and scanf. These are all just other things written in C code in these other files. The same way we're writing code in main C, There's other code that's been written in stdioh and standard libh. Well, using these processor commands, we can also define things. So let's go ahead and define a variable called max entries. And we'll say the max entries equal 3. Now, looking at that, you may say, well, what is really the difference? Why not just declare a variable? And this doesn't work the way a variable works. When you define something, you're not creating a space in memory where that's going to be stored. You're really just creating a synonym for max entry. So what the compiler will do is before it even builds your code, it will go through and find every place where you've entered max entries, and it will replace it with this piece of text. So naturally the question becomes, well, why would I ever use this? Why wouldn't I just type 3? Well, for one, it performs one of the functions for us that a variable normally performs, right? Is that if I use max entries 50 times in my code, and then later on I decide I want to do 10 max entries, I can change it in one location and it'll change it through my whole program for me. The second reason you might want to use max define, when we talked about creating our variables, we talked about creating meaningful names for them. That I want the variable to give another programmer a very good idea of what that integer is used for, of what that character is used for. And that's what we do with defines also. If I go through and I type 3 throughout the program, nobody really knows what 3 represents. It's an abstract, right? It's 3 of something. This gives them an idea of what that number represents and of what we're actually using it for. And that's why defines are so powerful. So we're going to go in and let's go through our program and kind of lay out what we're going to do. We're going to define 3 integers. And what this program, actually, let's do this. Let's do this a better way. The first thing we're going to do is we're going to tell what our program is going to specifically do. This program will tell the user the average number of push-ups they do per day. Okay? So that's what we're going to do. We're going to get a program that records user data for a certain number of days that they've been doing these push-ups. And then we're going to let them know on average how many push-ups they did per day. And we can make this algorithm even more fancy, right? We could determine how many calories you burn doing one push-up. And then we could return to them the number of calories they burn. The algorithms can be as complicated and can reveal whatever data we want them to. The structure of the program is what we're focusing on now. So how are we going to do that? Well, the first thing we need a place to store data, right? We'll say define 3 integers here. The second thing we're going to need to do is create a loop to run logic. And within that loop, we're going to have to get user entry for push-ups per day. And then we're going to have to track total push-ups. And once we get out of that loop, we're going to have to determine the average number of push-ups. And then we're going to display that to the user. Okay, so this is kind of our algorithm of how, our first statement up here tells what we're going to do. The statements that come after it tell us specifically how we're going to do it. So we're going to define 3 integers here. What integers would we need? Well, we need 1 integer to hold the user entry for push-ups per day. So push-ups per day equals 0. We're going to need another integer to track the total push-ups. Okay. And then we're going to need a third integer for the average push-ups. Okay. And this is the perfect program after the chili dog example. To kind of counterbalance things for us. So right now we have the max entries set to 3. But how do we tell the computer in our source code that we want it to go through and collect 3 instances of this data? What we're going to use is called a for loop. And what a for loop does is it says for this value, as long as it hasn't met this condition, then continue to execute this code block. Okay? And the syntax for that is that we're going to actually declare a variable in here. And you can call it day if you want to. For day equals 0. Or better yet, let's call this total days. And we're going to type a semicolon. So for total days equals 0, that's just giving it a variable to work with in the for loop. The next thing we're going to say is if the total days are less than or equal to the max entries. And you know, semantically, I actually like this better. Let's say entry. Let's call this entry. That's a better way of going about this, I think. As long as our entry is less than or equal to max entries, then we're going to say entry plus plus. Now, when we look at this code, we've got basically 3 sections. In the first section, we're declaring a value, and that's just a value that the loop can manipulate. In the second section, here, we're giving the loop its exit condition. As long as this statement isn't true, continue to execute the code block. And here, we're telling the loop how to manipulate the variable we declared. And in this case, we're going to use a plus plus. That's an increment operator. The increment operator in C++, can be used to add 1 to an existing value. So every time this loop executes, it's going to add 1 to the value of entry. And eventually, entry will no longer be less than or equal to the number of entries. And the code block will exit. So, first thing we're going to do here is get our user entry. We're going to prompt our user, enter the number of push-ups on day, and then we'll just use the number of the day, right? And we'll do scanf. We're going to expect an integer from our user, and then we're going to give it the address of push-ups per day. Okay. The next thing we do is we're going to track the total push-ups. I don't know why I had push-up in here as one word. Okay. So the way we're going to track the total push-ups, we're going to say I total push-ups equals I total push-ups plus I push-ups per day. Okay? So every time the user gives us a new number of push-ups, we're going to add that number to the total, and that'll give us a running total for that loop. Next thing we're going to do, we talked about operators in a prior lesson. We're going to say the average push-ups equals the total push-ups divided by max entries. And then we'll come down to the next line and we'll just display that information to the user. Okay. And there we go. A very simple program where we're going to loop through an algorithm and go ahead and collect some user data. We're going to perform an operation on that data. And then we're going to display that back to the user. Okay, and actually looking at our code here, I see one little error. This actually should be entry. We didn't use I. A lot of the time when people declare a for loop, they will use I as the name of this variable. And it stands for iterator or index. I prefer to use something a little more descriptive myself. And another quick change, let's go ahead and make this, instead of less than equals, let's just go ahead and make it less than. And we should be able to run this program. And we'll see our prompt to enter the number of push-ups on day 0, right? We started int entry at 0. And we can go ahead and enter, let's say 10. We did 10 push-ups on day 0. Notice now, instead of proceeding down here to calculate the average, the program actually starts over again. The loop actually starts itself over again. And now we're displaying day 1. And in the loop, what we see is the value of I now has changed. And let's say on the second day, we got bold and brash. We did 30 push-ups. And then on the third day, we were kind of tired. And on day 2, we were kind of tired from day 1. We only did 15. Now we can see after the third instance of the loop, right? As entry keeps increasing in value, the value of entry we can see is 2. When we increase it again, it becomes 3, and it's no longer less than max entries. This goes ahead and exits out, and we calculate our average push-ups. And then we print that back to the user. But looking at this scenario, right, how would we know? How would we know how many days that the user did push-ups? That's probably not something we'd know. And that's not something we'd want to define in our program, unless we had some kind of hardware limit where we just couldn't store any more records, right? We might want to use that as a hard define and put that in some kind of configuration file. But more than likely, we would not have that information, right? We would want to get the total number of days that the user did push-ups from the actual user. So you can go ahead and add an integer to track the total number of days. And we can go ahead and add some code here. Enter total days. And then scanf total days. And then make sure we're giving it the address. Now, instead of going for a max entry number of entries, We can go for a total days number of entries. All right? And then instead of dividing the total number of push-ups by the max number of entries, we can divide it by the total days that the user did push-ups. This is going to give our program a lot more flexibility. Let's say a user, we have a 30-day push-up program. Let's say the user says, "Hey, I've only been doing push-ups for 5 days. I just started." This allows him to enter the number of days he's been doing push-ups and get the result. And there's a lot more we could do to add to flexibility. This is just something simple that will show you kind of how these loops are designed to operate. So we'll enter the total number of days. We'll say this user has been for 5 days. And 10 push-ups, 15 push-ups, 20 push-ups, 25. He's getting stronger, gradually, little by little. And he ends up doing an average of 19 push-ups per day. But total days could be 100. It could be 1,000. It could be 50. It allows us to take a user's input, and now we scale the program based on the user's information. Okay, and that's the basics of a for loop. You're going to find that loops, condition statements are a part of every program, the same way that variables are going to be a part of every program. The same way that input and output in some form or another are going to be a part of every program. So for loops aren't the only way that we can accomplish our goal. So if you want to move to line 21, or wherever you have your for loop, hold the shift key, move over to the end, and we can go ahead and eliminate that loop. And instead of typing for, this time we're going to type the word while. So the for loop basically says for every iteration of this variable until we reach a certain condition, execute this block of code. The while loop is similar, but it has a little bit different semantic to it. So in this case, we're going to say while total days, In this scenario, we're going to go up here and we're going to declare a variable current day. Okay? If you remember when we did our for loop, we had to declare a variable within the for loop. You can't do that within a while loop. So we can say current day. And just like we did in our for loop, we can increment. And we can say while that value does not equal total days, then we're going to go ahead and execute the code in our loop. You could change this, right? You could do this a little differently. You could say less than, because we know we're starting at 0 and we're going to be going up to total days. And usually less than is more specific than not equal to, right? So usually it's better to go with more specific, because not equal, if this number starts out as 200 and your total days is 5 and you keep counting up, well, you'll never get to 5, right? And you'll have a program that has some odd behaviors that are hard to predict. So we can see here that we have a while loop. And while the current day is less than the total days, we're going to execute. And we'll see that this actually operates the same as it did when we had the for loop. Oh. Instead of entry, we now have current day. So we just need to make that change. Notice again, our handy compiler error checks us, make sure that we're not making simple mistakes. So the total number of days, we'll say 10. Enter the number of push-ups on day 1, 5, 10, 20, 60, 100, 24, 78, 42, We're really getting in shape now, guys. We're doing great. 99. And then on day 10, 12. And we did an average of 45 push-ups per day. You will notice that the last one started at a 0 counting index on the for loop. And in the while loop, we ended up starting on a 1. And the reason that is because with the while loop, in order for this to be identical to the while loop, we would have to increment current day at the end. So, excuse me, for it to be identical to the for loop. So in the while loop, when we increment here, it increments this value in this statement. So 0 becomes 1. And then here it prints 1 in push-ups on day in this print statement. If you wanted this to look exactly like the for loop, a for loop executes the increment statement at the end. So if we do this one now, we'll see that now it has a 0 index like our previous program. Okay. So there's literally nothing that you can do with a for loop that you can't do with a while loop. And there's nothing you can do with a while loop that you can't do with a for loop. But they are structured differently. And they're structured differently for a reason. Because sometimes one is more convenient than the other. But you're never really pigeonholed into one or the other. Okay? So now we move into lesson 5, functions. We've kind of gone over how to get user input, how to display information to the user. We've seen how to control the flow of our program, right? So we can execute different logic based on that user input. We've also looked at how to keep our programs going until certain conditions are met. But now we need to look at how code needs to be organized. How can we organize our code for reuse? Well, the way we do that is through functions. We've already kind of been introduced to functions, right? Printf, scanf, those are actually functions. Inside of those parentheses, we provide the code with certain arguments, and the code provides us with certain functionality. So the next thing that we're going to learn is how we can develop and create our own functions to get custom functionality out of C. So how do we start here? How do we go ahead and declare our function prototype? Well, the first thing we already know, we're going to give it a data type. We're also going to give it a function name that's descriptive of what the function does. We're going to find area. Now, the third part of the function that goes within the parentheses are the function arguments. The function parameters. This is going to describe to the compiler the data this function needs in order to operate properly. We already kind of know what that is, right? It's going to be the length. So we're going to have an int L. And these could be floats. You could use doubles. You could use some of these other data types that we've learned about. For the purpose of simplicity, we're going to use int. And then we're going to have an int width. And we're going to end our declaration with a semicolon. So what this does is it tells the compiler that we're going to be defining this function and that this function should be ready for use within our main. And what we're going to notice here is that when we go down to do our function definition, we'll notice that our function definition looks a lot like main because main is a function definition within itself. And you can see here that main returns a data type of int. And we can see we use the return keyword to return that value. And we're going to do something very similar down here at the bottom of the screen. So we're going to go ahead and now define our function. We're going to use our code block braces, just like we did for our for loops and our if loops, so that the compiler knows when this function is called that we're going to run this block of code. And what we're going to do here is we're going to say return length times width. Okay. Very simple, guys. And that's all we need to define our function. Now, as we've seen before, main is a function, right? Sometimes we end up with 20, 50, 100 lines in main as we get going in a program. And some of your functions you'll find will end up with 20, 30 lines. You want to make them as succinct as possible, but not all your algorithms will be this simple. But the structure will always be the same. Okay. Now I'm going to show you another quick thing here. When we're declaring our variables, we don't have to list them one per line. We can list them out in this format and declare our variables as well, if we want to. Okay. And now what we want to do is we want to get our user input for length and width. And we're going to declare another variable here. We're going to declare car C. And we're going to say that car C equals Y. And before we get our user input, we're going to start a loop, because what we want the program to do is we want it to run over and over again and get the user's input until the user wants to quit. Okay. So we're going to say while the character is Y, we're going to go ahead and get user input. And here's an interesting thing. I don't think we've done this with scanf before. But scanf doesn't necessarily have to collect one variable at a time. Scanf can collect data in almost any format. It just relies on the user to enter data in the proper format. So we're going to go ahead and grab our length, then we're going to grab our width. Okay. Once we have our length and width, we're actually going to call our function. We called printf, and we called scanf. But now we need to call another function that allows us to find the area, and we're going to call our find area function. And we know that find area needs two arguments to run effectively. We can see them here. We need the length and we need the width. Okay? So we're going to give this function the length and the width that the user has entered. And we actually are going to need one more variable here. We're going to need a variable for area. Initialize it with a value of 0. Now this function is going to return an integer. So what we'll do is we'll say that area equals the result of find area. And then we'll go ahead and display that to the user. Oh, we kind of got things a little out of sorts here. So go ahead and move this down. And see what the area is. The area. And we'll prompt our user again. And this time we want to ask them, would you like to enter another? Okay. Then we'll just go in and do scan C again. Okay. So what we have here is on line 7, we have a function declaration that will tell the compiler that we're going to have some functionality associated with the term find area. Down at the bottom on line 33, we describe to the compiler exactly what that functionality is. Then we have a conditional loop that is going to continue to operate as long as the character that the user enters is a Y. And this way the user can put as many links in and widths in as they want to, get as many results as they want to, and quit the program whenever they're ready. So one thing we're going to do here is if we're using this scanf in this way, we want to make sure that we use get car. And that's just going to catch the extra character in the buffer so that the next scanf doesn't pick it up. So right here we should have a functional program. Go ahead and run. And we can go ahead and enter our length and width. We're going to enter our length space the width. As you can see from our scanf function, that's the format it's expecting. And we get that the area is 200. It asks us if we would like to enter another area. And sure, why not? Let's enter one that's 30 by 50. All right. And you can go ahead and hit no. Incidentally, no could be any character you wanted to because we're only checking to see if it's yes. So, and we could add other things to this program too, right? We could do different stuff. Say if area greater than max area. Yeah, and then we could say the rectangle is too large, right? And we could either put in another user input to get the max area. We could go up here and we could do a hashtag define for the max area. Say, we don't want anything over 2,000. That's just too big. And we could even go in and define min area and say we don't want anything below 100. Those rectangles are too small. You might do a function like this, creating a grid for a game board or something. If you wanted the rectangles to be of different sizes for some reason. And we can see here, and then we can go down and we can say if area greater than min area. We'll printf rectangle too small. So I got a little typo here. Just go in and make sure we get our new line characters. Give it a build. Run. And this time we'll do 200, 200. That's interesting. Looks like we've got an error that the compiler didn't catch there. I wonder why our compiler wouldn't catch it. Aha. So here we've made the type of error that the compiler won't catch, right? This is a logical error. It's not that we've typed in anything wrong syntactically. It's just that we meant to do one thing and we've done another, right? This is a condition that's supposed to execute when the area is less than the minimum area. So let's go ahead and try this again. And now we can see we have a rectangle that is too large. And let's do a 4 by 5. And then we have a rectangle that's too small. Let's do a 20 by 20. Oh, that's actually a square, isn't it? And now we have an area that's just right. So that gives you an idea of how we can use functions and function arguments to express our algorithms in code. Let's say we had a program like this, and this program was 1,000 lines long, and we wanted to find the area in 1,000 different places in the code. This would be a much better way of doing it than typing out the equation over and over again. Generally, your functions will not be this succinct, though. They generally won't be a one-line function. You'll usually be doing 2 or 3 things to manipulate a piece of data before you're returning. But that just gives you an idea of how you can create functions and how functions can be used to improve your programs. We'll be creating more functions in subsequent lessons. Really, I'm trying to build you up here so that each lesson builds on what you learned in the past lessons and you get experience using these things over and over again. So one thing we're going to do here is if we're using this scanf in this way, we want to make sure that we use get car, and that's just going to catch the extra character in the buffer so that the next scanf doesn't pick it up. So right here we should have a functional program. Go ahead and run. And we can go ahead and enter our length and width. We're going to enter our length space the width. As you can see from our scanf function, that's the format it's expecting. And we get that the area is 200. It asks us if we would like to enter another area. And sure, why not? Let's enter one that's 30 by 50. All right. And you can go ahead and hit no. Incidentally, no could be any character you wanted to because we're only checking to see if it's yes. So, and we could add other things to this program too, right? We could do different stuff. Say if area greater than max area. Yeah, and then we could say the rectangle is too large, right? And we could either put in another user input to get the max area. We could go up here and we could do a hashtag define for the max area. Say, we don't want anything over 2,000. That's just too big. And we could even go in and define min area and say we don't want anything below 100. Those rectangles are too small. You might do a function like this, creating a grid for a game board or something. If you wanted the rectangles to be of different sizes for some reason, and we can see here, and then we can go down and we can say if area greater than min area, we'll printf rectangle too small. So I got a little typo here. Just go in and make sure we get our new line characters. Give it a build. Run. And this time we'll do 200, 200. That's interesting. Looks like we've got an error that the compiler didn't catch there. I wonder why our compiler wouldn't catch it. Aha. So here we've made the type of error that the compiler won't catch, right? This is a logical error. It's not that we've typed in anything wrong syntactically. It's just that we meant to do one thing and we've done another, right? This is a condition that's supposed to execute when the area is less than the minimum area. So let's go ahead and try this again. And now we can see we have a rectangle that is too large. And let's do a 4x5. And then we have a rectangle that's too small. Let's do a 20x20. Oh, that's actually a square, isn't it? And now we have an area that's just right. So that gives you an idea of how we can use functions and function arguments to express our algorithms in code. Let's say we had a program like this, and this program was 1,000 lines long, and we wanted to find the area in 1,000 different places in the code. This would be a much better way of doing it than typing out the equation over and over again. Generally, your functions will not be this succinct, though. They generally won't be a one-line function. You'll usually be doing 2 or 3 things to manipulate a piece of data before you're returning. But that just gives you an idea of how you can create functions and how functions can be used to improve your programs. We'll be creating more functions in subsequent lessons. Really, I'm trying to build you up here so that each lesson builds on what you learned in the past lessons and you get experience using these things over and over again. Okay, so we see how we can use functions to organize our code in different ways and make our code more readable and more succinct. But there are other ways of doing that too, right? There's more tools in the toolbox than just encapsulating our logic in functions. If you notice here, we've used printf and scanf, and I explained to you earlier that there are preprocessor directives that allow us to include additional functionality into our programs. And I explained to you that we can use functions from those libraries and that we can create our own functions. Well, we can also create our own headers, and we can place our functions in there, which allow us to organize our code even further and allow us to group functions of similar types together, the same way that the C language has done for us. So we can take a function like, say, for instance, find area, and that's fine. We can declare that function here, but if you have a main program that relies on a lot of functions, it might be to your advantage to separate those functions into different header files in order to keep your main program from becoming cluttered. So what we can do, actually, let's do this way. There's an icon up here to add a new file, and we can add a new empty file. And it'll ask us if we want to add this to the active project, and we'll say yes. We're going to give this file a name of double.h, and we'll go ahead and select the default options. Now it creates for us a folder called headers, and that's what this .h stands for. It stands for a header. And what this allows us to do is to go ahead and write separate functions right in this file. We can create a function that say int double, and then we'll give it an int. Give it an int called num, and then return 2 times num. Okay, and go ahead and save that file. Okay. Actually, you know what? Let's call this function double num because we're doubling the number here. And functions like this, with variables, a lot of time it's a good idea to give them specific names. With functions, a lot of the time it's a good idea to give them kind of generic names that just describe the functionality. because we might want to use double num in other programs. We might just not want to double area all the time. Sometimes we might want to double the perimeter or just double any arbitrary number. So we can come here and we can add our preprocessor directive to tell the compiler to include double.h. And what this does quite literally is it just takes the contents of double.h, and before it compiles, it will just replace this statement with that code. So now instead of declaring the function here, we can actually just go in and use that function. Double num area. And we'll say that area equals double num area. So now what this is going to do is when the user enters the length and the width, we're going to find the area, and then we're going to double the area, and we'll print that out. Double the area. Is, and then we'll print whatever the number is. And this will tell us if we're in the max or the min, the same way it always has. So with that, we should be able to go ahead and build and run our code. And we'll give it two values. We'll give it 10 and 20. And we see that double the area is 400. So we can see that both of those functions operate. And we can run it again, do 20 and 30. However many numbers we want to run through. And then we can also see our max min logic at work, right? 200, 300, and we can see that that one is too large. So what else can we do? What else can we do with functions? Well, one of the things you'll find yourself doing with functions all the time is, well, look right here when we ran main, right? Inside of main, we've called all these other functions. We've called printf, scanf, getChar, find area, double num. And you can also do that within your own custom function. So if I have a function that's called find parim, and we're going to take a length and a width, we can come here and we can say this function equals return double num L plus double num W, right? So we can use our functions to call other functions, and we can build functions that way where we have small amounts of really tight and easy to test commands that we know work, and then we can build them up command by command until we get to something complex. So we can jump back into our main program here, and we can see where we found the area. We can go ahead and add another. Let's go ahead and add another integer. Let's store that in a separate integer. You can use parim or perimeter or whatever you feel comfortable with. Try to avoid using things like p or just a single letter unless the variable has a very short life. So parim equals find parim L W. And then we'll go ahead and print out the perimeter for the user. Okay. And we still need to add a new line here, don't we? And we should be able to go ahead and build this program. And now we can see both the double the area and the perimeter are printed. So you can see how this could allow us to start building up more complex functionality within our functions. Using compound functions that call other functions and use those behaviors to get more complex results and to alter data in more complex ways is part of the art of programming, so to speak. So there we go. So now that we've learned about functions, let's move on to another very important topic in C. That's pointers, arrays, and memory management. Pointers are really one of the things that set C apart from higher level languages like Python and Java. Pointers allow you to get low level access to machine memory and manipulate it in your own programs. In this lesson, we'll go over what pointers are, how they relate to arrays, and how you can use pointers in your loops and functions to do some pretty cool activities in programming. So now we're going to jump right in and kind of delve into pointers. What is a pointer? Well, the best way to explain a pointer is kind of to review how variables work in the C language, right? We've gone over this before, that when we declare a variable, what we're actually doing is we're telling the compiler to create a space in memory of the appropriate size for that data type, and that we want to reference that data using our human readable text, and we want to put this value there. Okay? Well, we can actually see what the compiler is doing with that information, right? We can type in the name of our variable, and then we can use %p, and this is actually the substitution character for a pointer value. Actually, I prefer X. Let's go with a hexadecimal. And let's type 0x %x. And then T. And then we're just going to print the integer value of inum. So for the first one, the hexadecimal, we're going to use ampersand inum, which, if you remember, ampersand is the address of variable. And then we'll just use inum, and that will get the value. We've seen this before with scanf, right? Where we've gone in and we've had to explicitly tell it the address instead of just giving it a copy of the value. And there we have it. This is our human readable text here. This is what we're going to use to tell the compiler to look into this address and get us this value. What a pointer is a pointer is a variable that stores this value. Inum stores this value. This value is stored in this address. We get to it using inum. A pointer to inum stores this memory location directly. So let's take a look. How do we declare a pointer? If I want a pointer, I tell the compiler what data type the pointer is. Then I type in the asterisk, which lets the compiler know it's a pointer. And by convention, we're going to go with a pointer. Instead of starting it with an I, we're going to start it with a P. Just so that we know that what's stored here is not actually an integer, that it is actually a pointer. Now, we can't set the pointer to the value of inum, but we can set it to the address of inum. And we can come down here, and we can print f, and we can say pnum 0x okay. And now what we can do is we can send the value of pnum, which is actually going to be a pointer. It's going to be the same as the address of inum, because that's what a pointer stores. It stores addresses. Then we can use something called our dereference operator. And what that dereference operator does is it tells the compiler, go to the address in pnum and get me the value. Oh, we forgot. I keep forgetting my new line characters, guys. Sorry about that. So I've got a couple typos here that impacted us. And there you have it. And there you have it. Pnum and inum, the value of pnum is actually the address of inum. And the value stored in that address is the same. This is the same location in system memory. And that's all a pointer is. It's just a reference to that address. Well, then why the big deal about pointers? I mean, what can you really do with them? What's the difference between having a pointer and having an address of operator? Why do we need both? That's a difficult question for new programmers. It's difficult for new programmers to understand why pointers are so valuable and such a powerful tool. And as you gain experience with programs, you'll start to learn that this is integral to understanding C and also to C++. Understanding this concept of a pointer and how you can use that to move through memory is what sets C and C++ apart from some of the other languages. We're going to be getting into that, and we're going to be getting into arrays and how to manage this memory. So what is an array, and what's the relationship between arrays and pointers? Let's start that out. Let's start exploring that by declaring an array of numbers. We'll say 5 numbers. And you've seen this format before, right, when we've worked with characters. This is telling the compiler to give us 5 contiguous spaces in memory capable of storing an int. And in this case, we can specify those numbers. Right, 10, 30, 10, 20, 30, 40, 50. Okay? And what we want to look at is, one, what type of data is actually stored in inumber? We can very easily go through the values in inumber, right? This is 5, right? We can go through and we can look at each value in each position in inumbers by looking at the ints and telling the compiler that we want the number stored in this index. Okay? And what it will do is it'll go through each value in inumber until it gets to the 5th value. And let's space this a little bit with a new line. Oh, that's not what I meant to do. All right, there we go. And there we go. We can see that those are the numbers that we've stored. But we can't see where they are, right? We don't see them in contiguous memory. Well, we can. So let's go ahead and change this to a tab. We'll do %p for pointer. Actually, let's do x. That's a little better representation to me. Okay, and proceed it with a 0x. And what we're going to do now is we're going to ask for the address of inumber I. Okay. And let's go ahead and add a new line character. So we can print these each out on a new line. Make it a little easier to read for us. Okay. So now when we look at it, not only can we see our values, but we can see the contiguous memory addresses where they're stored. The first value is stored at 61FE00. Then the next value is stored 4 bytes from there. The next value is stored 4 bytes from there. 40 is stored 4 bytes from 30. And 50 is stored 4 bytes from 40. And these are hexadecimal numbers. So C is analogous to 12. 10 is analogous to 16. Okay, so we can see that our array is storing values in a contiguous manner in memory. One value after another, sequentially, one after one, as space is available in memory. But what is I number then? What is I number? I mean, I number obviously is not an integer itself, because integers just store values. Let's see if we can figure out what type of value I number is. Let's go 0x, x. Put that in quotes. And let's just go with I number, not the address of I number. We don't need to know the address of I number. We need to know specifically what is stored. What is the value of I number? If we go run our program, oh, we needed a new line character there, didn't we? And if we go run our program, surprise, surprise, the value stored in I number is the same as the address of the first number in the array. When we declare an array, the value stored in that variable is actually a pointer to the first element of the array in memory. The relationship between arrays and pointers is fairly simple, guys. Arrays, in fact, are pointers. They are just pointers with a greater degree of description and a little bit more functionality associated with them. Now that's interesting. But if I number is a variable, is a pointer that stores an address, how can we get to the value of it? How do we get to the value? Well, we've already seen one way. We can go through and access the index, right? We can go through and we can say I number. Give me the 0th index. Give me that first value. But what we can also do, because this is a pointer, is we can always get the first value by using our dereference operator. We can always tell our compiler to go to this address and give me this value. The same way that we can go in and tell it to go to get the value from this index. Okay? And we can see how these are kind of indexed in memory, right? They're one space away from each other. So what else can we do? If we put this in quotes to change the order of operations, and we add 1, what's going to happen here? What index are we at right now? Oh, missing a parenthesis here. What index are we at now? We're at the next index, right? We're at 20. If we change this to go along with it and say I number plus 1, where does that take us? The address is now 04 and the value is 20. We've moved from the first position to the second position. We can move to the third position. And now we can see the address is OC and the value is 40. Okay? We're just taking that pointer and doing some pointer arithmetic. We're telling the compiler, we're telling the computer to start at this address in memory and move along 3 spaces. And then we're using this dereference operator. And we're saying, now tell me what that value is. Here, we're telling the compiler, go give me this address that's stored here and show me what's 3 addresses up from that address, 3 addresses higher than that address. So, what are some of the reasons we need pointers, right? I mean, what is all of this about? What is all of it for? Wasn't it just simple enough to have values? Well, yes. Yes and no. Pointers can help you to understand a lot of the underlying mechanisms that are working within your code. Not to mention having a lot of utility and functionality just in generating code. One of the helpful illustrations of a pointer is in character arrays. What's the relationship between pointers and character arrays? Why is that so important? Let's say we have a character array called name, and it's of indeterminate length. And we're going to set that to John Adams. Well, we have kind of an issue here, right? Because if at any time during the program's life we want to change that value, Edward Munoz, we've actually got a problem here. We talked about defines before, but C has another concept, and that's a constant value. And whenever we declare a pointer as an array, it is a constant value. We just told the compiler that this variable points to the address of this first letter, wherever that may be in memory. And once we tell the compiler that, we cannot change the value. And you see when we try to compile here, we get an error. Assignment to expression of array type. We talked about how arrays are similar underneath the hood. But let's see some of the ways in our source code how they're different. And this is one of them. An array is a constant value. And what this does is it really tells the compiler to point this to this letter, wherever this is in memory, and we can continue to traverse from one block of memory to the next until we get to something that's going to be a null or an empty value. And then we have to stop. And we cannot change that pointer. The system cannot comprehend that that value can be changed. Okay? So let's take a look at what I'm talking about here. Okay. And we're going to do a print statement. We'll just go ahead and print the pointer. A new line. No, sorry. Let's print the pointer, a tab, the character, and then a new line. Print name I. The reference to name I. And then the value stored to name I. And then next we'll take this offending line of code that can't be run. And we'll remove it. And we'll go ahead and fix this little typo here. And we'll go ahead and run our code. And look what we see. We can see that John Adams prints, and each character is stored in contiguous memory. And each one of these characters is 1 byte away from the previous character, starting at FE11 and ending at FE1A. Okay, so that's an obvious limitation, right, of the character array. Even though it is technically under the hood a pointer, it's a limited pointer. It has some additional functionality with indexing that the pointer has a different notation for, but it is a constant, which limits its use. So what can we do here? Let's say we have a name too, and that's John Adams as well. Let's actually make this one Sam Adams, just so it's a different name. And we no longer need this loop. We don't have to loop through anything to illustrate this example. And we can go to printf, S for string, and we can print name 2. Then we can come down another space and say, well, you know what, let's change that name. Let's make it Mark Mellon. And then printf star S, name 2. And we see Sam Adams followed by Mark Mellon. So that's just one of the things we can do with pointers and strings that we can't do with arrays. You get a lot more flexibility when you use the pointer representation as opposed to the array representation. So what are some other cool things we can do with pointers? I mean, what are some of the other limitations that pointers might help us work around? We talked about functions before. Functions are awesome, but they don't always work for all inputs. So having a function that says int double me, that takes an integer as an argument is fine, right? We can kind of look from what we know about functions, and we can pretty much guess how this is going to work. We're going to take a double, we're going to take an integer, and we're going to double its value, and then we're going to return it here. Pointers allow us to do this in a different way. And there are reasons, why this is true. All of this C code goes down into assembler, which goes down into hexadecimal, and it generates actually different commands depending on the way it's written. And we're not going to get into that in this course, but I just want you to be able to understand this. Okay. And what we're going to do is we're not actually going to return anything. We're just going to say value equals 2 times x. And we're going to go here and say int num equals 10 and int value equals 0. So what's the big deal here? What's the difference? Right? Why couldn't we do this without a pointer? I mean, we passed variables into functions before. That's no big deal. Well, technically we didn't pass variables into functions. What we did was that we put copies of variables into functions. So let's look at how can we get our variables into our functions. Because that can be important sometimes. We talked about this before when passing copies of objects. What if we have a large object that we need to pass into a function? It's not very efficient to create a copy of that object. What if the object is a gigabyte in size? It's not very effective to pass a copy, to make a copy and then pass a copy of that object into a function, then return another copy of the object from the function. So how do we handle this? Say dealing with ints. What we need to do is we need to go ahead and declare a pointer. And instead of setting its value to 0, we'll set it equal to the address of a variable of its same type. And as a quick kind of exercise, just a bit of a sanity check, we're going to go ahead and print out some values here. And the first one we're going to print out is the address of num, and then its value. Then we're going to print out the address of result. And its value. So, address result and its value. Make sure our formatting is correct. Then we can print out the address of value Note that we just print the pointer, right? We don't print the address. And then we dereference the pointer to get the value. And we should see a little magic happen here that we're familiar with. Oh, forgot the new line characters. Let's get the new lines in here. Oh, got a couple little buggies here. Okay. The new line after each. And there we go. We can see that num is at one address and that the pointer value is pointing to the same address as result. And both of the values are the same, obviously, as 0. So let's say we have a function called double me. Right? We have a function called double me. And we're going to pass that function some variables. We're going to pass it a number, and we're going to pass it a place to store. We're going to pass it a place to store the result. Okay. Change this to num. That value is going to be 2 times num. Now what we're going to see, or what we should see, is that the address of value will be the same as the address of value always was. But the address of num is actually going to be changed. And then when we're done, we're going to go ahead and print these again, just to make sure that we didn't do any hocus pocus, right? There wasn't any real change to the address of num. It's just a change to the address within this scope. Okay, and one quick change we're going to have to make here, guys. On line 29 here, we've assigned a 2 times num to the pointer value. In order to do this properly, we need to dereference this pointer so that we're assigning not an address, but a value. And to do that, we just use our dereference operator. And when we go ahead and run this code, well, we see what we expected to see, right? We can see that num started out at an address of 14, E14. And the value was 10. But when we get to our second print statement, which actually operates inside of this function, we can see that the address of num is now df0. Same value at a different address. That tells us that the compiler made a copy of this value and stuck it somewhere else. This way, this allows our function to operate and make changes to this value within this scope without affecting the value of the variable in this scope. Now, sometimes that's desirable, and sometimes it isn't. Now we can also see that we created a variable pointer called value, and we set it to the address of result. And we can see here in the first print statement, E10 is the address, and obviously what's stored in that address is going to be the same. When we look at the value, the address of value in our second statement inside of the function, we can see that the address of value remains the same. The address of value remains the same. And that is because we didn't pass it a copy. We didn't pass it a copy of the variable. We passed it a pointer to the variable. And that pointer is going to have a value of this address. Now, you might make an argument, well, mechanically, doesn't it do the same thing? Doesn't it always make a copy? And here I'm just copying the address, and here the value is actually the number. Well, yeah, that is true. But semantically, philosophically, what we're doing is we're telling this to operate on this address in memory, and we're telling it here to operate on this value, not at all on the address in memory. So when we come here and we dereference value, we're telling the compiler, I want to be able to store something in this address. And what we're going to store is 2 times num. When we get down to our third print statement, we're going to print out num, which we can see outside of the scope of the function is back at address E14. The value is still 10. But what has changed is E10. E10 is now 20, and that's what we did here. We told it to put this value at this address. Well, what address? Whatever address I give you when I call this function. And we can see here that we gave it the address of value. And that's how pointers work in functions. There may be times when you have values where I just want to utilize that value in the function, but I don't want the function to change it. In that instance, you may use a copy if the data that you're passing in isn't too large. If you want to be able to manipulate the data, you're going to pass it a pointer to the data, and that way you can allow the data to be changed. So that's the basics of pointers, guys. We went over how to declare them, how to utilize them, how they relate to arrays, kind of a little bit of pointer arithmetic, how we can move from pointer to pointer in sequence to look at sequences of data. We're going to be moving on to structs now. So really quickly in this lesson, we're going to be learning about structs. A couple things, the main things you need to know about structs is that they allow us to create complex or compound data types. It allows us to take existing primitive or normal data types in the language and combine them into a singular entity that defines something else. Think about this like say you've got a spreadsheet and it tracks data on a particular person, their name, weight, and their job classification. Instead of storing those separately in 4 separate variables, we may create a amalgam of those called employee that we store in a C struct. Structs are powerful. They allow us to take those groups of name variables and create a singular entity with which we can reference them all. So, guys, jumping right into learning about structs here. As I said before, structs are going to be a way that we can take related pieces of primitive data and combine them into something more meaningful and something more complex. So, when we talk about primitive data, we're talking about our base types, right? Our base data types, our ints, our floats, doubles, cars. And then from these data types, right, we can expand on them with arrays, right? We can have an array of numbers, right, if we wanted to, or any combination of them. But let's say we're writing a program and we're being asked to represent points on a Cartesian plane, right? And if you're not familiar with what that is, it's just a plot with XY coordinates, right? And let's say we want to represent that. We're going to say int x equals 0, int y equals 0. Okay. That's fine, right? We can use that to plot a single point anywhere on the plane. But let's say we're being asked to plot multiple points along the plane. Well, there's one way we could go about that, right? We could say int x2, int y2, and on down the line. But at the point where we got to 100 points on the plane, well, now this system looks like it's not very efficient, right? We end up typing in a lot of code and creating a lot of variables that really aren't necessary. So another way we could go about this is we could try to solve the problem with an array, right? And that gives us 100 x points and 100 y points. And the way we would reference those is that, int x1 would always be paired with y1, and x2 would be paired with y2, and so on and so forth. We could even do it in a way that said points 200 and have every even number point be paired with an odd number point, right? We could do that too. But what happens when each point on the graph, they come to us and say, well, okay, yeah, we need the points, but we also need the points to be related to an ID number. And the ID number is going to be a string of characters. Well, now we've got a bigger problem, right? Because we've got this name. We'll actually call it a unique ID. That's a car. And we'll say that the unique IDs have 8 characters. And now we've got int x, and we've got int y. So it's easy enough, right, to relate int x to int y using arrays. Easy enough to maybe even to do the car, right? We haven't talked about 2D arrays, but that's a thing that we could use. But the simpler solution and the better solution is to use what we're going to call a struct. Is to get out of the whole convention of individual primitive data types and to get into a structured form of data. What happens when we have a database field, right, that we're trying to represent and manipulate in the program, and this database has 20 different columns of data associated with it? What happens when we get into problems where we need to create 100 different instances of the same group of data, and we need to do it in various scenarios? Those other methods could get very confusing. What the struct allows us to do is to declare a group of data as a singular entity. And we're going to call this struct point. And this struct is going to have a UID that's 8 characters long. It's going to have an X coordinate And we can just leave that blank. And a y coordinate. So what this allows us to do with our structure is to create new entities of type point. So what can we do with this struct, right? I mean, how do we manipulate this powerful tool in its simplest form? Well, the first thing we have to do with this struct is we have to create an instance or an object from it that we can manipulate. So when we do that, the first thing we need to do with the compiler is to tell it that we're not using a primitive data type, that we're using some structured data. And we can do that simply by typing in struct. The next thing we're going to type in, you can probably guess this, is going to be, well, what type of struct is it? Well, it's a struct of type point. And the third thing that we're going to use here, we've been working with variables long enough that you can probably guess. We're going to give it a name that we want to use to reference the data. And that's really all there is to it. At this point, we can go in and we can say, we can talk to our user through the console and say, enter the point ID. Right? We can grab that string from our user. Now, this is something that we haven't had to do before. So we're actually going to have to reference that point. And then that point, in order to reference the data contained inside of the point, we need to use what's called an access operator, which is a period symbol. And then we can go ahead and say, well, this is the piece of data we want to access. And we want to give you a reference to that piece of data. Okay? Okay. And we don't have to worry about that right here, right? Remember our lesson on pointers. We learned that an array variable is actually a pointer to the first address. So when we tell it UID here, we're already telling it an address. And then we can go here with our integers. Enter the first point. Well, we'll say enter the X coordinate. And then we'll say scanf. And this time we will say address of X. Or no, we won't say address of X. We'll say address of point X. And then we'll enter the Y coordinate. And when we're done with all that, we'll just give a little bit of feedback here. All right, just finish up our display here so we can look at our values. We'll go ahead with the X chord. Give our code a quick look here. Typo. Put our semicolon at the end. And then we can just finish our output statement here. Xcord. I'm not sure why I capitalized these, but that's all right. can go ahead and use sPoint.uid. Point.x, xPoint.y. All right, and we should be all set. And we can just give it an ID A, B, C, D. Our coordinate can be any value that does not exceed the parameters of an int, and that can be any value. And we can see that we're able to store values in that structure and print them out by referencing the point that we declared, and then using the access operator, the period, to access the primitive type of data. Okay, we just want to make sure we have our project selected. And we go to this new file icon. We're just going to click new file. We're going to select empty file. And it's going to ask us if we want to add the new file to the active project. And we're going to say yes. We're going to call this file employee.h. And we'll select all the default options. So before we talk briefly about header files, right, and how we include these header files, and if you go onto your computer, you can actually locate these files, and you can see that there's code inside of here with functions and different data defined. And we're leveraging that code here to call scanf and printf, so that we don't have to write these, this functionality into the code ourselves. We can just utilize what's already written. Well, in this case, we're going to actually be making our own header file, and we're going to call it employee.h. Okay, and we can go ahead and eliminate all the code that's here. We're going to be working in a header file. Okay, so the first thing we're going to do in our header file is we're going to include a file. We're going to include stdio.h. Okay, and that's just the standard input-output library. Then we're going to define a struct. And this time I'm going to show you a different way of defining a struct that allows us to use it more specifically as a type. So we're going to define our struct. And instead of telling it, the compiler, what we want the struct to be called in the beginning, we're actually going to do that at the end. We're going to go here and we're going to say typedef, which tells the compiler that I want to define this as a type. And it just allows us a more flexible way to use our structs in our code going forward. So the first thing we want to do is we want to add some data to our struct here. And we're going to have a name field where we're going to store the name of the employee. We're going to have an integer field where we're going to store the hours the employee worked. We're going to have a float field, which is for floating point numbers, decimals, which allow us to have a higher degree of precision than integers. And we're going to store the pay rate. Then we're going to have another float where we're going to store the check amount. And this is how much the guy gets paid. Okay. Now, we've kind of gone in and we've done this already, right? We just did it already in the main file. We want to change that up a little bit, okay? We want to define some functions that are going to be associated with this structure. And we talked about this before, right? We talked about how we can use header files and functions to organize our code better. Can you imagine a program that had 1,000 different structures, 100 different structures, 20 different structures, all defined in the same file? Even at 20, that's a lot to define in main. You kind of want to break those up. How would you know which functions are meant to operate on which structures if they were structure specific? This way, we'll be able to break up our code in ways that are reasonable, and it'll be very easy for other people to reference these. So we're going to go in here and we're going to say we're going to define a function called setEmployeeName. And it's going to take an argument type of employee pointer. This is going to be a pointer to an employee object. So we're going to be giving the address of an employee object that we can manipulate within this scope. And the only thing we're going to do when we set employee name is we're going to return scanf So this is something new, right? Before we talked about the access operator, right? That period symbol. Well, when we're using a pointer to access the members of a struct, the data members of a struct, okay? Whenever we do that, we need this operator. This is the operator, and it's a minus sign and a greater than in conjunction with one another. This tells the compiler that I want to go from this pointer, okay, and I want to reference this space in memory that's associated with this pointer. And as we already know, CA name is actually a pointer to the first space in this car array. So this will give to this function this address where this is located. Okay? So just to go over that really, really kind of slowly, this function is going to take an argument, and that argument is going to be a pointer to an employee object. It's going to be an address where one of these employee objects is stored. When we call scanf, we're going to use the address that we send into the function, and then we're going to tell it we want to access this field, this data member that's associated with this object. Okay? The other thing that's new is that scanf actually does return a value. And it returns a certain value if the scanf fails. And that's the only reason we have a return int here. We're not even going to use it. Just kind of know that that's available. And normally if you were doing this, you would return the error state or the status, right? And that's kind of one of the other points of functions working this way, right? If I can put the data here, I can return the status that the function returns here. You'll get more into that as you get more into programming, more into intermediate type of code. So we're going to go set pay rate. Actually, let's change that. Let's make it more specific. Set employee pay rate. Okay. And same thing, we're gonna have a pointer, and we're gonna return scanf. In this case, this is going to be a float, and we're going to return the address of pay rate. Okay. So you see what we're doing here? We're giving an address to the function, and we're saying there's an employee object stored at this address. Okay. And then we're going into scanf, and we're saying, okay, we're going to get a piece of data that's going to be a float. And we want to store that data in this address. So we give it the first address, which is the address of the employee structure. And then there's also an address where this specific variable within the employee structure is stored. And we're using the address of operator to tell it that's where we want that data to go. And we're going to do that again here. We're going to do that for set employee hours worked. Okay. And you know what, in this case, we'll make it a little easier on ourselves, right? And we can just change this to I. And we can just change this to I, hours worked. It's the same thing here. We're just going to give it an address and say, hey, at this location, I've got an employee object. That employee object has an integer value for the amount of hours worked by this employee. I want you to put a value in that address for me so I can reference that at a later time. So what else do we do with functions? We don't just set variables, right? What else do we do? We perform calculations. So let's calculate employee pay. And let's do another employee pointer. And the reason these all have to be pointers is because we want to change the actual values being stored at that location in memory. Otherwise, we would just be passing a copy of the data, and all of the things we tried to change would only be changed within this small scope. And we want to change these values out in the larger scope, out in the larger program. So here we go again. We have this address that we're sending, and we want to access the check amount value. And we want to set that check amount equal to the pay rate times the hours worked. So this is a little more of a realistic programming scenario than just an example. And this is the kind of thing and the kind of calculations that people do in programs every day. Sometimes, obviously, a little more complex than just a simple multiplication action, but a lot of time it isn't. A lot of times you're just, performing something very simple. And then we're going to have another function that we're going to use. Most of the time when we do these, we do an input, process, and output cycle, right? So we're going to encapsulate all of that in this header file. So instead of calling standard library functions, we're going to be calling the functions that we've written that are specific to this data type. And we're going to be doing that right here in this file. Notice we're not using a pointer here. And why aren't we using a pointer? Well, we could. We talked about this before. What if this struct held tons of data? What if it was a huge struct with a lot of data in it? Maybe it wouldn't be to our advantage to pass this by copy, right? Maybe that would be a really inefficient operation. But in this case, it's fine. And I just really want to give you guys an example, that we can do this multiple ways. Okay. Hours worked. Put the hours worked as an integer. Pay rate. Check amount. Okay. And then we're just going to do our comma here, and we can list everything that we want to use in substitutions. You don't need to hit enter there and to go to the next line. I just do this because it looks neater. And you'll notice here that we're no longer using this operator that is associated with the pointer. We're going to be using this access operator this time because that's the one that is associated with just the data, and we're not referencing an address here. Or at least we're not directly referencing an address, I should say. Okay. So we're going to go ahead and save that. So now we can move back into our main file, right? And we've created all this functionality, and we've got our structured data here in our header. How do we use this? Well, actually pretty simple. We just include employee.h in this file. And now all of the functionality from that employee header file, all of that functionality is now here. Now, if you notice before when we declared our struct, we had to type out struct, and then we had to say, well, what kind of struct? Well, it's an employee struct. And what do you want to call it? Well, I want to call it employee, right? One difference with this struct is we actually did a type define on this struct. So now our struct is defined as a regular type. We don't have to worry about telling the compiler that we're dealing with a struct. We can just declare it. So now we have our employee object, right? But we also have this functionality here. We have this functionality that we've set aside for this object type. And what we can do now is we can just, instead of doing what we normally do, we can just go ahead and we can call our functions on this object. But there's one thing we didn't do here, right? Because this function looks for a pointer. So it's not looking for an object, it's looking for a address. So we do our address of operator. Another way we could have handled this is we could have declared this to be a pointer initially. But for now, we're going to use our address of operator. Okay? And if you're using code blocks, you should notice that, a lot of this will auto-populate for you, right? We can go ahead and do hours worked and employee. And then we can go through and set, right? We can set the employee's pay rate here. I know we set these to return integers. We're just going to let it return these into the black abyss of the machine here. We're not going to actually use those return values. In a real program, you probably would use those return values. You would probably check those with a conditional statement to ensure that the space in memory was writable. It's not normally a problem, but in order to be safe, you do want to check those things. And when we get to our kind of our mini project later on, we will get into that. So now we've set the employee name, we've set the hours worked, we've set the pay rate. And next thing we want to do is we want to calculate the employee's pay. And then we can go ahead and print the employee. And for print employee, if you remember, we're not sending an address. We're sending a copy of the object. We could send an address. It would work if we sent an address. It would change the syntax just slightly. But I just wanted to do this to show you kind of the different ways that we can use this same object. Sometimes making these copies is not a good idea. And sometimes giving a function access to your data is not a good idea. And those are situational. It's more of an intermediate programming thing that has to do with data access. But for now, we've got a functional program here, guys, and we're going to show you also how we can extend this and get something a little more realistic. And you can probably guess how we're going to do that, right? We're going to incorporate some loops here that allow us to work with more than one object and allow us to work with a dynamic number of objects or some certain number of objects. All right, so we've got our little program here. Let's just go back and take a look at our code. One change I did make, if you didn't have F pay rate here, that should be F pay rate with the float preceding. Once you make that little change, you should be able to go ahead and run your code. Now, we didn't put any prompts in here for the user to know what to enter. So you're not going to have the advantage of that. But the first thing you enter is going to be a name, followed by an integer for the number of hours worked. We'll put 40. And let's say, entry-level programmer probably makes about 50, 60K. That's about, I haven't been an entry-level programmer in years now, but it's about $25 an hour. And there you go. We can see that Jeff worked 40 hours this week at a pay rate of $25 an hour, and his check amount is $1,000. Okay? So that's another way to use structs in a more realistic sense, right? Normally, we wouldn't define every structure for a program in main. To be honest with you, you want to do as little in main as possible and as much in your headers as you possibly can, because everything that goes in the header is logically arranged, right? Everything in here is in here because it has something to do with these employee objects. Main is kind of where you really just want to be tying all the threads together. But this still isn't actually a realistic program, right? What we really want is we want to have our input, process, output, which we kind of have that here. But also there's some normal expectation that this program will scale, right? That what's the point of an employee program that only allows me to enter one employee? If you want to pause the video here and maybe give a little bit of thought to some of the things we've learned with arrays, some of the things we've learned with loops, and how you might use those two concepts to extend this program and make something a little more reasonable, I would go ahead and do that now. If not, you can go over it with me here in a few seconds, and we'll kind of look at how we can leverage those two concepts to allow us to use these structs a little more effectively. Okay, guys, so given what we already know, right, how can we make this a more realistic program, right? Well, the first thing we could do is just kind of, enter employee info. And I think that's enough for now, right? We kind of get it and we know what we're doing here. If you want to go through and change these functions to have prompts, or if you want to put the prompts in between these functions, feel free to go right ahead. But the important part, and what I want to get across to you guys, is in a more realistic program, right? We might have some constraint, right? And it says, hey, the company can only have so many employees, right? And we'll say 256. Actually, let's say 1,024. Let's say 1,024 employees, right? So how do we extend this program and make this program to be more realistic? Well, one of the first things we could do is we could say that, you know what, instead of having this just be a program that deals with one employee, let's increase our capacity to the maximum number of employees that our backend database can hold, right? And we'll increase that to max employees. Now, some of you are probably thinking, well, what we should do here is create a for loop. We should create a for loop for the maximum number of employees, right? For int I 0 equals 0, semicolon I less than max employees, semicolon I plus plus. Well, that's one way of doing things, right? That's one way of doing things where we can allow users. However, there's a problem there, right? I mean, what happens if we don't want the user to input all 1,024 employees at once, right? What happens if we just want to keep that as a maximum? Well, we can give them another way of doing things, right? We can create a different kind of loop here that checks the value of the user input for a certain character. Let's say if the user wants to quit, we'll allow them to hit Q, right? And we'll just store that in a character input. And that's simple enough, right? And then instead of a for loop, maybe we'll go here and we'll say while user input does not equal Q. As long as the user doesn't tell us, hey, I want to quit this program, we're going to allow that user to keep inputting employees. So how we're going to accomplish that is we're going to go ahead and use scanf, which we've used in the past. This time we're going to do something a little bit different because a lot of time there ends up being a stray new line character in the stream. We're going to tell scanf to expect a new line and then to go ahead and capture the user input. And we're actually going to move print employee up. Well, no, actually, yeah, let's move print employee up. Go ahead and move print employee so we can see those print out in the actual loop. And this will allow us to capture as many employees as we want to. Well, it'll allow them to input as many as they want to. But we're actually not capturing those, right? Because every time we're feeding an employee in, we're not feeding in a different employee. So we want to put something in here that allows us to track which employee we're inputting. So what we can do here is we can start with an integer, and we'll call that integer I, the same way we would in one of our for loops. The only difference is what we're going to do here is every time we successfully input an employee, and you guys might remember this from a previous lesson, right? We're going to iterate and increase the value of I by 1. And what this will allow us to do is to use our indexing for our array. Okay, and we will just add our semicolon so we're properly punctuated. And we get our prompt to enter employee information. We can just enter test 1, 20, 30. And this is the hours and the pay rate. And it should go ahead and calculate for us. In this instance, we can just enter C to continue. You can enter anything except Q in the third slot. You can however, go ahead if you want to and just put print prompts here to make things a little easier for you. And we'll say this guy makes $30 an hour, or worked 30 hours a week, makes $40 an hour, and we want to enter another guy. So we'll go with test 3. Please don't try to enter whole names, right? Because in our employee name function, we really only set it up for first name. You could add another variable to the struct for last name, and you could populate it there using scanf. But we didn't do that. Didn't fit the purposes of our lesson. So 40 hours work, $40 an hour, and then we'll choose to quit. And we can see that all our information, test 1, test 2, test 3, have all yielded the appropriate results. All right, guys, so that gives you a bit of background in Structs and how to structure your data, a little bit of how to organize your code during header files, and most importantly, how we use structs in code and the different things we can use them to represent. And also kind of, how we can use header files, right? How we can use them to organize our code in reasonable ways. And you'll see as you get more into this and as your programs get larger and larger, these points will take up more of your time and will require more of your consideration. And the more you're able to hit the nail on the head with code organization, the more you're able to hit the nail on the head with how to structure your data properly, the easier it's going to be to develop your algorithms and to develop your functions. So we're going to be moving on and kind of one more tool I want to put in your guys' tool belt before we get you into a project, which is really where your learning is going to start to expand. The last tool we want to get into is standard input output and also how we deal with files. So we've gone over this input, process, output loop that's really at the heart of programming. And so far we've been using printf and scanf for formatted input and output. Well, there are other standard methods of getting input and output, and there's also other sources of input and other places where our output can go besides just the console. And one of the most common ones is to use files. So that's what we're going to kind of be going over in this lesson. We're going to go over this input, output, process loop using files instead of using user input, or using combinations of the two. So sit back, relax, get your text editor, your IDE open, and we'll get into lesson 8, input, output, and file handling. All right, guys, so here we are back in our Code Blocks IDE. And so far, we've been kind of exploring this input, process, output loop and how it relates to problem solving with C. Well, what happens when we end our program, right? What happens when we get to return 0? Well, what happens there is everything that was in our program that we were storing and referencing in memory, all that memory is returned to the OS for other programs to use. And essentially, all the processing we've done, everything we've output is lost now. What happens when we need programs where the user needs to be able to access that data at a later point, or to have the program pick up where it left off? What happens when we need some kind of persistent program that doesn't just start itself over again with no information every time it exits? Well, what we do in that case is we move our data from volatile storage, which is memory, which disappears. For our purposes, it actually disappears when the program exits. And we start to store things in files. So how do we work with files in C? Well, C provides us with a really easy programming interface for working with files. Essentially, we're just going to type in all uppercase, the word file. We're going to create a pointer to a file object. And for this example, we'll call it pfile. So right now, what we've done is we've reserved a space in memory for the address of this file object. In order to associate an actual file on the hard drive with this pointer, we're going to call a function called fopen. And fopen takes 2 arguments. One is going to be the name of the file. Lesson 8.txt. And the second argument it takes is the file mode. And what the file mode tells the compiler is how we want to use this file. And we've got a couple options here. We've got basically read. Okay. We've got write. And we've got append. To use the read option, the file must exist. Now, obviously, we haven't created any files yet, so we won't be using the read option. For the write option, we can have a file that already exists, or we can have a file that doesn't exist, and this function will create that file for us. The append option requires a file that already exists, and what append does is it will start writing at the last written line of the file. If you ever use W, which we're going to use now, please be aware that this will empty the contents of the file if it exists. Okay. So anytime we open a file, we really want to do this check. Because there could be any number of reasons why the operating system would not allow us to create this file. Whenever we call fopen, we're basically sending a command to the operating system saying, hey, create this file for us. There might be any number of reasons the operating system says no. So before we proceed, we want to make sure that the file actually gets created. Okay? And that's what this does. So if fopen can create the file and everything goes well, it returns the pointer to that file. If it cannot, this value will remain null. It'll remain 0. So we're telling it here, if we can create the file, and we're going to learn a new way of doing input and output that I think is going to be a lot of fun. Okay. So we're using this function fputs, and fputs takes 2 arguments. It wants to know the string that you want to write to the file, and it wants the file pointer. Okay? So fputs is very similar to printf. It's very similar to printf, but the only difference is fputs will put a new line character at the end of that string for us. And fputs takes a file argument here that we can write to. And some would consider this a more convenient way to write to a file. So we go ahead and eliminate this. And the last thing we want to do here, we open a file. We always want to make sure that we end by closing a file. And simple enough, we can go ahead and run this code. And we can see that the process returns 0. Our code executed successfully. You can go back to projects, right-click, open project folder in file browser, and you should see your lesson 8 text here with the appropriate text printed on the first line of the screen. Okay? Lesson 8. Okay. So let's say we have a file now, and we do. We have lesson 8 text is a file on our system. What we can do, and let's say we want to be able to get an input, is we can change that W to an R. Now we're going to be reading this file. Okay, and we'll go here, and we'll create a variable called myString. Better yet, let's do CA for character array myString, and we'll just give 100 characters. We know our string isn't that long, but that's fine. So now we'll have the file opened, and we'll have a string to store it in. Go ahead and erase this condition here. And instead of using fputs, we're going to use a function fgets. And the first argument to fgets is where you want to place the data. And in this case, it's going to be CA myString. The second argument that we're going to use is going to be the size of the input. And in this case, it's just the maximum size of the character array. And then the last argument we're going to give is the pointer to the file. Okay. And what we want to do next is we want to print this to the console. We want to print the value that we read from the file, and we want to print that on the console so that we can see it. We're going to use, instead of using printf, we're going to use a function called puts. And puts does a very similar operation. To printf. As a matter of fact, this same command in printf looks like this. So a lot of the time, puts is just a more succinct, convenient way of doing things. This is the equivalent command in printf. Okay. And we can go ahead and build and run. And we can see the text lesson 8 appears on our screen as it was read from the file. So that's simple enough, guys, right? It's kind of this input, process, output loop that we've been working since the beginning of the series here. The only difference is now we're doing it with files instead of a console program. And we can actually go in and view our data after the program is closed. That the data remains persistent. It's still there somewhere on the drive. So what I want to do really quickly, and some of you guys who are a little more ambitious, feel a little more comfortable, is I just want to do a program here where we're going to take user input from the console and print it to a file that we can view later. So I'd recommend you pause the video, give yourself a chance to work it out. Working through these problems on your own is what's going to make you a programmer. In the tutorials, you're learning the language basics. You're just learning how to speak to the computer. Knowing what to say and when to say it is a problem-solving skill that makes you a full-fledged programmer. And it's something that you'll learn in time. The more active you get with these tools and in programming communities, discussing these topics back and forth with other programmers. And for those of you who still aren't quite comfortable at that level, you can just kind of let the video go and follow along with me. But that's what we're going to be doing here. We're going to be getting a user input, and we're going to be printing that user input to a file. So what we're going to do now is just kind of expand on this idea with files and input-output just a tad, okay? So what we're going to do now is we're going to do a program that's going to take a user input, and then we're going to print that user's input formatted to a file. Fairly common, simple programming operation that you'll likely run into quite a bit. So the first thing we're going to do is we're going to create a struct to hold our data. And we're going to call that struct employee. We're going to have car, CA name, 25, car, CA title 25, and car, CA department 25. Okay, so the struct is just going to hold three strings that'll help us define the employee. And for CA name, actually, let's go ahead and make these 50 characters. Let's give ourselves a little bit more room. So we're going to go ahead and create our file pointer. And what do we do next? We've created a pointer to a file object, and the next thing we have to do is we're going to open a file. And we'll just call it, actually, let's call it employee text. And what are we going to do with employee text? Well, we're going to write. We'll then create an employee object to hold our data. And at this time, when we print to the console, let's not use printf. Let's use puts. And we're going to ask them to enter the employee name. No need to use the new line. Puts will add the new line character for us. As a matter of fact, if you add a new line at the end, it will give you a superfluous line. So then we're going to use, instead of using scan F, we're going to use gets. And we're going to get the employee CA name. Okay. One limitation that we noticed with scanf is that scanf by default stops recording characters at a space. So when we ask for a name, if you remember in that tutorial, we could only get, we just said we were going to do the first name for the sake of argument. Gets actually does not have that limitation. So we'll go with puts. We'll enter the employee title next. Gets. CA title. Then we'll do puts. Go to the employee department. Just a little formatting stuff here. And then we'll do gets. And we'll get the department information. Now, we've got a couple options here, right? We've used fputs before, right, to print things out. But in this case, we want our data to be formatted in a very specific way. And for that kind of operation, the printf, scanf functions that we've been using in the past really do the job probably better than our other options. So let's go ahead and instead of typing printf, we're going to type fprintf. And this is the file version of printf. We're going to give it our file name. And we're going to give it our string that we want printed. Okay. And the extra dots, it's just a formatting thing to kind of make this look nice and neat. And remember, we're using fprint, so we do need to add our new line. Each one of these functions, even though they kind of perform a similar task, they each do have their own little quirks about them. Oh, sorry about that, guys. This is actually employee name, title. And employee department. And there we go. All right, and just clean up a little typo here. There we go. So we can look over this program. We're creating a struct. We're defining that struct as a typed so that we can assign it here. We're creating a file object, opening a file. We're going to use put s, which stands for put string, to print information to the console to our user using the standard output. We're going to get string from the standard input. We're going to do that for all of our fields. Then we're going to call fprintf, okay, to print to our file. Okay, guys, so let's go ahead and run our program. And it asks for the employee name. We remember that kind of that limitation we ran in with scanf. Don't have that problem with get string or get s. We can just type in employee name, Walter Mosley, my favorite authors. We'll say that Walter Mosley is the sales manager and he works in sporting goods. And we can see our program complete and exit. And we can go over to our files and open employee text. And there you have it. And what this does is this creates a storage location for data so that if I was having someone go through data entry and enter all these employees' information, when they came back to this program, I could pull up and read the information from this text file and give them those employee records back or allow them to come in and edit a certain employee record. There's a lot you can do here, and this is just the basics of it. Okay, guys, and here we are Getting started with the final project here. This is the the portion in this tutorial where we kind of go through, we take everything you've learned so far and we tie it together. So far it's been kind of little bits and pieces, right? And we've kind of built on things a little bit, but not to a full-scale program. And that's what we're going to do here in the next half hour, 45 minutes or so, is to go ahead and build this program. It's a small, simple program that makes use of all the skills you've learned up until now and shows you how they fit together in a cohesive project, and hopefully gets you started on the path towards learning intermediate C and towards developing and planning your own projects, which is going to be a big part of your learning process. The basics you get from tutorials. To get to that intermediate level, you've kind of got to code things out, and you've kind of got to come up with problems, and you've got to solve them programmatically. So let's start that process now. The project I have planned for you guys is a project I'm going to call the bank project. And what the bank project is it's a small banking program with limited functionality. The program is going to allow users to perform transactions on accounts that they create within the program. And the program is going to keep a log in a file of all the transactions that occur. And the project does have certain specifications. There'll be a document associated with the tutorial that you can kind of view that gives those, and we'll kind of go over them really quickly now. So the first specification, the first thing this program is going to do is going to display the program name and the version number. And most of you can probably already think of how you would do that, right? That's a pretty simple output operation. The next thing the program is going to do is it's going to prompt the user to enter a menu option. Okay. And the menu options are going to be open new account, deposit, withdraw, transfer, print account data, print account summary. Okay. And the third thing the program will do is it will maintain a log file of all actions. Everything the user does has to be accounted for in a log file that we're going to create and maintain. Now, the details of each one of those will be contained in a document. And you can view that document. I would recommend that you at least take a look at the document and go through and just see how much of this you can get done without following along with me. I think number one, most people, at this point, everyone should be able to do number one. Number two, I'll give you a quick hint if you haven't started already. If you want to try it on your own, go ahead and pause me now, shut me out, and go with your idea. But it's going to be, if you remember, we did this earlier, right? We had this kind of loop that would run. And it would run until the user told us that they wanted to quit. And that's exactly what you're going to do for your menu. Now, as far as each individual menu option, now we get into a little bit of the processing part of it, right? Every one of these options has some processing associated with it that we're going to have to do. And those are your mathematical operations. Some of these are just going to be, in the case of print account data, we're just going to be printing whatever account they give us. And there's going to be a little bit of lookup, some comparisons that we're going to have to do. If you think about your conditional statements, all of that is about to come into play, and we're going to meld it all together here. So how do we start, guys? How do we begin this process of meeting these requirements, these specifications? Well, what I like to do, and what I mentioned before, is I like to kind of go through and just write comments that describe to me what I'm going to have to do. One of the first things I know I'm going to have to do is I'm going to have to define the maximum number of accounts. That has to be done. We have to give ourselves a limit to the number of accounts that can be created. What is this account going to be? How are we going to represent this account? It's going to have a couple of different variables associated with the same concept. So what I'm going to want to do here is I'm going to want to create a struct for accounts. Okay. We know that that's something we're going to want to do. At some point in this program, we're going to have to get user input. So we're going to create a variable to store menu input or user input, however you want to look at that. And we're also going to have to log operations, right? The instructions say we're going to need a log file. So we're going to have to create and open log file. Okay. We also know we're going to need somewhere to store all of our structured data for all of our accounts. So we have to create an array of accounts. First requirement is to display the program name and version. And one of the things we've already learned is that, programs generally run in loops. We're going to have this program running over and over again until the user tells us to quit. He or she wants to quit. So we're going to create a loop to run our program. And once we're inside that loop, we're going to want to print menu options so that the user can select one of the 6 operations. We're going to want to get the user input, and we're going to want to process user input. Okay, and that's our basic loop, right? We're gonna come in here, and this is where we're going to be doing our input, process, output, right? So the last thing we're going to want to do here is update status to user, right? We're going to give the user some kind of message to let them know what the current state of the program is after they've selected their option and we've performed our process. So to get us started here on our mini project, first thing we're going to do is we're going to define the maximum number of accounts, and we're going to say it's 1,024. Actually, let's not go that high. 32 accounts should serve our purposes, but you can set the limit wherever you want to. Then the next thing we need to do is we need to create a struct for our accounts. And we could do that in this file, but I'm perceiving that there are going to be some functions and some operations associated with that struct. So what we're going to want to do is we're going to want to create a separate file for our struct. So there are a couple of different ways to go about this, right? We could go in and go ahead and create our header file for accounts and start building our functionality. Or we could kind of build a little bit of a harness here in main for how we wanted our program to start. And we've got some low-hanging fruit here, right? Some simple things that we already really are straightforward and we can jump right in and get them done. One of them is create a variable to store the menu option. Well, we can just use a character, right? We'll take a single character input from the user and we'll set that character value to any letter of the alphabet. Next, we have create and open a log file. Well, we've done that before, right? We know we can use the file data type, and we can create a pointer to that object. And we'll just call it logger, because that's its purpose. Okay. Any of you guys remember how we're going to open this file? There's a function at our disposal that allows us to open that file. And we give that file a name. And this is a file that we are going to write to. Okay. Create an array of accounts. Well, we're going to save that for later. We don't need to do that just yet. Displaying the program name and version number. Well, a couple of different ways we can do that, right? We know about printf. Printf could be useful in this scenario, right? Because we may want to make the version number a variable, right? We may have a different about screen or a help screen where we print the version number. But we don't have that in this program, so we can just make that a literal string where we can say, welcome to bank account manager version 1.0. If you want to try to do something a little fancier with that and maybe do the printf and have a variable or even a define that stores your version number, that's also a good idea here. Then we're going to create a loop to run our program. Okay, so this loop is going to be a while loop. And we're going to be looking at the user input, and we just want to make sure that it doesn't equal Q. Because we're going to say that when they enter Q, that means that they want to quit. And we'll have to convey that information to our user within our program. And the perfect place to do that is in the print menu options. So in print menu options, we can just use put string. And we can kind of put our menu options in here. 1, open new account. Okay. You could also use another convention here. Some people prefer this, where it's just the first letter. Sometimes when you have commands that, you never know if you're going to have another command that starts with an O, and then that method can get a little bit difficult. So I just prefer to number them. We're going to do a deposit, right? As we can look up top and see that that's our next function. We'll put another. Withdraw. We'll put another. Oh. Transfer. We'll put another. Print account data. We'll put another. Print account summary. And then we'll put one more. And this one we will use the letter because we use numbers for all the other ones. And this will say quit program. Okay. So right now we should have a program that really now results in an infinite loop where it will actually just print this message and then the program will hang. So the next thing we want to do is we want to get user input. And we've done this before, right? We've used scanf for this before, and we've got, excuse me, we've got other methods of doing it as well. Okay, but for now, we're going to go ahead and use scanf. And that will go ahead and grab our character from the standard input, which is our console. So the next thing we're going to do here after we get the user's input is we're going to process that input, right? We have to do something with the input they gave us. And in order to look at that character, we're going to use a switch statement. We could use a series of if statements. If input equals 1, if it equals 2, if it equals 3. But this to me is a lot simpler. And I think when you see it, if you want to try it with if statements, go ahead and try it that way. But I think you're gonna see that the code is gonna come out cleaner my way. So for case 1, that is the option to open new account. Okay. We'll just leave it there. And don't forget your break at the end, right? If you don't put that break, what happens is every case falls through to the next case. And for now, just for testability, we're just going to put a string that tells us which option our user has selected. Okay, very simple. And a couple of little syntax errors here. Okay. And what did we forget? Of course, we forgot the all-important break statement. So hopefully you guys type those in. Hopefully you're doing as I say and not as I've done. But we can go ahead and make that correction here. And then we're going to have a case for Q. All right, guys, and just a couple of syntax things that we need to clear up here. Comma, if you did single quotes here, we need this to actually be a string literal and not a character. So that ought to resolve those. All right, guys, so the next thing we're going to do is just give us our default case. This is just in case they type in something you didn't expect. And we'll tell them invalid input. And just looking over our code, we probably don't need to print hello world anymore. Looks like we're missing a comma right here. And you can check over your own code for any typos you may have made. This actually should be double quotes and not single. Other than that, looks pretty good. One other thing we need to do if we're going to get characters using scanf like this is to come down here and just make sure we clean the buffer if there's an extra character. So we're going to use put C. And put C is kind of like put S, except for it only captures one character at a time. And there's also obviously a get C, just like there's a get S. But you can just type this in, and this will catch the extra character that may be in that buffer. Okay. So now we should be ready to go ahead and run our program. And we can see we fulfilled 2 of our criteria, right? We've got a message that says welcome to Bank Manager and gives the version number, and then we present our user with his or her options, and then the user can go ahead and make a selection here. If he selects 1, we see open new account, and just go through your options, make sure they all work as you expect. Withdraw, transfer, print account data, print account summary, and before we do quit, let's do 7. And we should see an invalid input, which is our default. and then uppercase Q should go ahead and quit our program for us. All right, guys, so we've got the basic structure of our program working here. And sometimes that's a good way to start. Some people prefer a different kind of development where we would actually create the account file first and kind of create these unit tests, just testing each function one by one to make sure they work. For small projects, sometimes it's better to set up the actual structure of the program first and make sure you have that working. So this is just one way of going about things, to go through, kind of type out what you need to do in comments and then fulfill each one of those requirements one by one. So we've kind of got our input, right, and our process, or at least our input and output really going. Now we've got to give some attention to our process. We've got to start doing something when we activate these options in our switch. And the way I want to attack that problem is to go ahead and create an empty file. And we will add the file to our project here. And we'll call it account.h. And the good thing about code blocks is it knows to go ahead and put account.h right there in our headers. And this is where we're going to define what an account actually is. The first thing we'll do is we'll kind of look at, well, what do we need for this account, right? A couple things we need is we need to be able to return to the main program a status every time it calls a function. So what we're going to do is we're going to define success as 1, and we're going to define error as 0. Second thing we're going to do is we're going to need to do some standard input-output operations here. So we'll go ahead and include the standard input-output, SDIO.h. Next step is to go ahead and define our functionality. To define our data. And every account we do is going to have an integer that represents the account's ID. And a floating point number that represents the account's balance. We could add a lot of other things in here, but we're going to keep this to the minimum. You guys can come back later on and, if you want to expand the project on your project, you can add a name or even maybe account types, right, that allow different operations. But for now, we're just going to keep it basic, and these are just going to have account ID and account balance. And we're going to go ahead and call this account. So what do we need our account to do? Well, option 1, right, is that we need to be able to create new accounts. Okay, well, the first thing we want to do is define what is the return type of our function. Well, we already said we're going to be returning to main a status, and we defined our statuses as success and error, and they are both integers. So all of these functions we create are going to return integers. So we're going to go ahead and create a new account. And this is kind of where software design comes in, right? Determining how we're going to go about this. The way I've determined to go about it is that we're going to pass a pointer to an account object into the function. We're going to pass a float into the function. That's going to be the amount of money used to start the account. And we're going to pass a file pointer into the create new account function. And we're actually going to be passing a file pointer and an account into all of these functions. Each and every one of them is going to have a file pointer and an account object. Passing the file pointer is going to allow us to manipulate an account, and passing in the file logger is going to allow us to use fprintf to maintain our log file. So the first thing we want to do here is we're going to write a conditional statement. So as I mentioned before, every time we run one of these functions, we're going to return to the main whether the function was successful or not. So when we start an account, we know that our deposit has to be greater than 0, right? And if our deposit is greater than 0, and you know what else we're going to have to pass into here? Not only an account object, but in this case, we're going to have to pass an account ID. So every new account we start will have an account ID and a balance. So we can go ahead and take our account, and our account ID equals ID. And our account balance equals the deposit. And then we're going to have fprintf, and we're going to place our logger in as the first argument. And then we're just going to say account creation success, account, and then the account ID number. And that's just going to be the ID. And once we've done all that, we'll return success to let the main program know that the account has been successfully created. Now, if that isn't the case, and if deposit is actually less than or is 0, then we're going to go back and we're going to put another entry in our log file, a different entry in our log file, and we're going to say that account creation failed for the account number. And then we're going to let the main program know that it failed by returning an error. Okay. Now, even though the next function, in order is the deposit function, what I want to do is I want to go ahead and put in a account print function. And this function, probably we shouldn't have an issue with this function having an error, but we'll go ahead and put one in there anyway. And we'll say that the account and file logger and the only thing we really need to know here is, do we have a valid account? Is the account null? And then we'll say fprintf to the logger file, printed data for account, and then whichever account it is. And this time we'll take the actual account ID because the account has already been created and it should be ready to go. Now fprintf is going to print to the file, but what we want to do is we want to print something to the user in the console and let him or her know the information that they're looking for. So we're going to go ahead and say account ID and then the ID, new line, account balance, and then we're going to have a float there for the number of dollars in the account. And then account ID, account balance. Okay. And once that's done, we can return success, which will just return the value 1 to the main program. If for some reason we fail to print we'll say that we'll return to the log file and say that print data for account failed. Okay. And then we'll just show which account ID it failed for, and we'll return the error message. Okay, so here we have an account structure, and we have a couple functions here. One that allow us to create accounts, one that will allow us to print account data. Now, the reason I want to stop here is because I want to get something testable, and these two functions are enough to allow us to start testing. So we go back to our main, and we can see here that initially we plan to create an array of accounts. So we can say account, accounts, max accounts will be the number of accounts that array can hold. And there's no need for it to hold anymore. That's the maximum. Then go down here and open new account, which is our first option, and we do have a function for it. Well, we can't just call that function, can we? There's some data that we need for that function, right? Let's just go here. Okay. The first thing we need is we need an account, right? We need an account object. The second thing we need is the deposit amount. The third thing we need is an account ID. And then we need a logger file. So, well, how do we know which account we're dealing with? We need a variable that allows us to iterate through the accounts in this array. So the first variable we're going to create is I, total accounts. And we're going to set it to 0. Okay. And that's going to allow us to pass a specific account object into this function, starting at the 0 index of the array. And we're also going to need to get a deposit amount. They can't start an account here with no money. So we need a float that is just the amount of money they want to start the account with. So the first thing we're going to have to do here is prompt the user to enter the deposit amount. And then we can scan the console for a float, and we can put that in amount. Okay. Now that we have a variable that tracks the total number of accounts, one thing we want to do before we create a new account is to create a conditional statement that makes sure that the total accounts is less than the max accounts. Make sure that we're not going off the boundaries of that array, and make sure we're not breaking a business rule by creating too many accounts. Okay. The next thing we want to do is another condition statement. And this one's going to be something a little different than we've done in the past. We're going to say if create new, then we're going to pass an account object into the function. And this is the same function we created here, right? So we're going to say if account create new, account I total accounts, F amount, and then the next argument here is the ID number of the account. And we're just going to use a sequential pattern here. So the total accounts and then the plogger, which is the log file we need to pass. Now, how can we do this, right? What does that mean when we say if this function? Does it mean if this function exists? Well, let's take a look at the function and let's take a look at what we're doing here. Because if I was to call this function, it's going to return to main an int, an integer. And in this case, it will return either 1 for success or 0 for error. So what this actually does is it calls this function, it runs the code in this function, and when this executes and it completes, it's going to return a value. Okay? In C code is always true. And this is always false. So whenever you use an if statement with an integer variable, what the compiler does, how the compiler interprets that, is to say if this equals 0, it is false. And if it equals anything other than 0, 1, 2, 3, 4, 5, 6, 7, 8, anything other than 0, negative 20, then it is true. So in this case, if we say if a function, we're saying if it's successful, do this, whatever's in this code block, and if it fails, do this. It's handy. It's handy and it helps you to write nice clean code. Okay. So if we're able to create the new account, then we're going to take the total accounts, we're going to increase it. We're going to say, well, now we don't have 0 accounts, we have 1 account. And we're going to let the user know that account creation was a success. If it fails, we don't really have much of anything to do, except for just to give the user the courtesy of a feedback that lets them know that their account creation failed. Okay. In this if statement, go here and create an else, and just say account limit reached. Too many accounts. So this is what's known as a nested if statement. The compiler is going to evaluate this, and if it's true, it's going to go down. It's going to say my next line is another if statement, and I need to evaluate this as well. If this is not true, it's going to move straight to the else and perform this function. Excuse me. Well, it will. It will perform this function. Puts as a function. So let's go ahead and try to do a quick build. And we can see it says here that account is undeclared. This should actually be accounts. And we need a semicolon here. So let's go ahead and build. Doesn't mean our code works. It just means that we've gotten the basic syntax correct. The next thing we want to do is the print account data. Okay, so whenever the user selects option 5 and they want to print account data, what we need to do is we need to find out from them what? Which account? They need to enter their account ID. Okay. Now, in case 1, we didn't really worry about the account ID, right? We're just giving it the account ID. We're incrementing it. Here, though, the user could enter -500. And if they did, it would cause us some problems, right? there's never going to be an account negative 500. And if we pass that into the function is going to process as if there's a account 1024, and we're going to have an issue. You know, whatever number they enter, it's going to process as if it's valid. So we need to check that. And that's what we can use a conditional statement for. We can say if the account ID is greater than 0, actually greater than or equal to 0. Now, we could use a nested statement here and say, well, if it's greater than or equal to 0, and then if that's true, another if, or you can type these two ampersands. And basically this tells the compiler that account ID is greater than or equals to 0, and simultaneously account ID has to be less than total accounts. And if both of those are true, then we're confident that we have an account that is valid. And we go ahead and print our account for the user. And then give it our plogger. Okay. And if not, if that isn't the case, then we just need to say print error. Then we need to say invalid account. Now, because we're checking for, there should never be a situation where account print actually returns its error. Okay. But if you wanted to, you could do the same if check that we do here and let them know that their print operation failed. Okay, so we can go ahead and do the build icon. And we do have a couple errors here. Let's see. It's telling me that my variable account ID does not exist, and that's true. So one more variable we need, guys, is we need an account ID. We have to be able to track account IDs. Okay. And here, I made a mistake. This is actually going to be account ID. And a semicolon. Don't go too far without doing a quick build, just to make sure you got all your syntax and everything correct. So now we can add an account with a certain amount of dollars, and we can print out account information for that account. And one more thing that we need to add is another character grab right here. So we have one here at the end that's going to handle if we have to grab any characters in this sequence, and one here to handle the overflow character that we'll create when we put that first variable. Okay. And the last thing we do is right here before we do the check on account ID, we're going to get the account ID from the user. Okay. There's a little bit of room there. Okay, so let's go ahead and test what we have here. And we can see our menu. We can go ahead and open a new account. We'll deposit $500. And then we'll print the account data. The only account we have is account number 0. And we can see account ID 0, account balance $500. You can add another account, and we'll say this account has $10,000. And now we'll print account 1, and we'll see that account ID 1 has a balance of $1,000. Okay. So at this point, the next easiest thing to do is to go down here to print account summary, which should allow us to print all of our accounts. And that's going to be a simple for loop. Right? For int I equals 0, I less than I total accounts, and then we'll increment I. And then we'll just go here and we'll say account print, whatever the value of I is at that time, and then we'll give it the plogger, the pointer to the file. And now this should allow us to print all the accounts that we create. And we can go ahead and test that. Oh, wait 1 second. Oh. Extra parenthesis there. And let's open a new account with 20,000. Open a new account with 50,000, with 50,000, and then go ahead and print the account summary. And now we can see our 2 accounts with the account balances. Now, if you notice here, our values look a little bit odd, don't they? We're printing way too many zeros at the end, and we can fix that. Let's go ahead and Q to quit program. We can go back into our functions here. And right here, we can precede this with 0.2f. And we can also add a $sign at the beginning. Okay, and that should pretty up our print statements. And you can do this for any precision. It could be 5 after the decimal point. It really doesn't matter. In our case, when we're doing dollars, we want to have 2 after the decimal point. Go ahead and save that file. Okay, so now we see we can add accounts. We can print out accounts after we add them. We can print out a summary of accounts. And we've checked off 3 ticks on our to-do list here. The next thing we're going to do is we're going to add the ability to deposit into our bank. And the first thing we're going to have to do when someone wants to make a deposit is we're going to have them enter the account ID. We got to know which account they're depositing. Okay. Then we can scan. Get account ID. Easy enough. We're going to do the same check. We're going to do the same check we did here. As a matter of fact, we can just copy this check up here. We're going to do the same account validation. And you know, after you get to the point where you're using the same logic over and over again, it's a good time to ask yourself, you know, hey, maybe this should have been a function. Maybe this should have been a function called validate account ID, where they pass in the account ID and pass in the total number of accounts, and we check it against that. The way we've done it here is fine. It's not a problem. But just a design choice. We could have done it differently, and maybe that second way would have led to code that's a little bit cleaner and a little more readable. Okay. So if account deposit, we're going to pass it an account ID. We're also going to pass it an F amount, and we're going to pass it a logger file. Okay. So what do we know here? Once we have a valid account ID, what we need to do here is we need to get the deposit amount. We need to scan. For that amount. And once we have our amount, because the deposit can fail, right? The deposit can fail if this amount is less than 0. We can't deposit a negative amount into the account. So we need to do a conditional check, make sure this succeeds. And if it does, we'll let our user know deposit success. If that check doesn't succeed, we let them know that the deposit error has occurred. Whoops. Can't do that. So let's do this. We also have this check. We also have this first one. So we can also come here and at the bottom we can say invalid account ID. So for our deposit funds, we're going to go through and make sure we have valid account ID. If we do, we're going to get the amount of the deposit. We're going to call our function, make sure it returns success. And if it does, we're going to let our user know, okay, your deposit went through. Now, this is all fine and good, but there's one thing we haven't done yet. We haven't created an account deposit function. So when we go to call this code, the compiler is not going to know that this exists. We have to go back into our account file, and we have to create an account deposit function. And we know that this is going to need a pointer to an account. It's going to need a deposit amount. It's going to need an ID. And it's going to need access to a logger file. You know what? Actually, let's not do that. We don't have to pass this an account ID. We can just pass it a specific account here. So first thing we're going to do is check to make sure that the deposit amount is greater than 0. Then we're going to use this plus equals operator, which tells the compiler that we're going to take the value of the left-hand side and we're going to add this value to that. Okay? So whatever the balance is, we're just going to add this to the balance. Then to make sure we keep our logger up to date, we're going to do a file print. We're going to say we did a deposit to this account ID. Okay. And we're going to say we did a deposit for this amount, and the balance is now this amount. So we're going to have the account, and then the account ID, deposit, and then account, account balance, and that will fill in these one by one. The same way we do it with a regular printf. This just prints it to a different location. And then we're going to return success. We're going to let it know we successfully did the deposit. If not, we'll just say fprintf logger deposit failed. Okay. Up, little typo there. Okay. And then we'll just tell it which ID that it failed for in the log. And so the reason we're doing this with the log is the log is just a way to go back and audit the system later if something's gone wrong. And let's go ahead and try a build. And our build was successful. Now we have an account deposit function. But you know what? The account withdraw function isn't really much different, right? It's not much different from this one. And it's going to take all the same variables. And we're also going to want to make sure, we'll just change the float to amount so it makes sense semantically. We're also going to want to make sure the amount is greater than 0. And then we're going to want to change this so that the amount is subtracted from the balance. And we're going to want to change this so we say withdrawal made. And then instead of printing this deposit amounts, which is not in the scope of the function, we're just going to print that amount. And then down here, okay. There are a couple of different ways we could have done this. We could have done this actually with a single function and forced them to pass in a negative amount for withdrawal, and then we could have had just one function that said update account. Is another way we could have done it. I prefer it this way actually when we're using that switch statement. And let's go ahead and try to build. Okay, good. So now we can come down here, and for withdraw funds, it's actually pretty easy, right? We really just are going to take everything from deposit funds and we're going to paste it. Minus this line that says deposit funds. We'll get them to get the account ID. We'll enter the withdrawal amount. We'll call the function withdraw. And then we'll tell them that the withdrawal was a success. Wow. I mean, you see how fast that went, guys. We are now down to one final requirement, and that is the transfer function. Here's the thing, guys. Programming is all about thinking, and it's all about problem solving. Given what we've been able to do here so far, create accounts, okay? Deposit funds, withdraw funds. I really would like for you guys right now to pause the video and to not even go back into amount. I mean, you could go back into account and you could create a function there that transfers funds if you wanted to. Or you could just go here and look over your logic. I mean, essentially, a transfer is a deposit into one account and a withdrawal from another. And there's probably an additional check that you're going to have to do. You know, there's a little more logic there, right? We're going to have to look and see, well, are each one of these accounts valid? We're going to have to get 2 account numbers from the user and make sure they're valid. We have to make sure they're not the same account, right? We have to make sure we're not withdrawing and depositing into the same account because that doesn't make sense. But at the same time, it's a zero sum operation. So maybe we don't have to worry about that. Maybe you do want to present something to the user that says, hey, you're trying to do that. But I would like each and every one of you right now at this time to go ahead and at least attempt the transfer of funds function. Okay? And before you do, you should be capable at this point of going in and testing your deposit and withdraw functions. You should be able to go in and go ahead and create a new account, add some money to it after it's created, withdraw some money from it after it's done. You should be able to test some of your error conditions at this point by entering values that you know don't meet these conditions. Okay, so go ahead and attempt those two things, and then we'll kind of walk through it together. So hopefully you've had a chance to at least attempt to transfer funds portion of the project. It's the most complex portion of the project, but it is also in some ways simpler because you're not going to do anything here that we haven't already done somewhere else in the code. So I kind of wrote out a little algorithm for us that describes the steps we're going to take to achieve our goal. And the first step is we're going to get and validate account information. We can go into almost any one of these steps and we can see how we get and validate account information. Not a difficult task for us at this point. We're going to get the amount of money to transfer. Well, we've done that before too. And then we're going to process our transfer. We're going to withdraw and verify withdrawal. We have to verify that the withdrawal was successful before we can deposit. And some people at this point might be thinking, well, why do I need to verify my withdrawal? Shouldn't I also have to verify my deposit? In this case, we do not have to verify the deposit. And the reason we don't have to verify the deposit separately is because if you look at the check that we put in place to verify the deposit, it's actually identical to the check that we put in place to verify the withdrawal. So if this one succeeds, we know this one succeeds because the value being evaluated does not change from one to the other. Okay, so we have a little special circumstance that allows us not to have to do this separate verification here. Now, if the criteria here were to change, or the criteria here were to change, then it would be we would have a different solution that we would have to put in place. So the first thing we're going to do is we're going to get and validate account information. We can look up here on line 106 and see, hey, we've done that before, right? We've actually done this before. So let's go ahead and just copy that piece of code and put it into place. We're going to ask them to enter the account ID, and we're going to put the account ID that they enter into a variable, and then we're going to evaluate that variable. And the only thing we're going to do is, if the account is valid, is we're going to go ahead and, for our user's convenience, we're going to print that account. And of course our log file so we can track all of this. Okay. We're going to go ahead and print that just so they can see how much money is in the account before they decide on the amount they want to transfer. What if it doesn't work? What if it's not a valid account? Well, obviously we can't go forward with our logic at that point. So we want to let the user know that the sender ID is invalid. And then we want to break. We want out. We got to get out of here. Okay? So we're going to break out of the condition at that point because there's no further work that we can do. there's other solutions to this too, right? We could go back and ask them for another ID if we wanted to. We could create a loop that allowed them to keep inputting IDs um, until they got one that was valid. But in this case, and those are all things you can try when you go back and you look over this code and you want to, kind of change things around and kind of stretch your legs with the language a little bit. But for now, we're just going to tell them that that's an invalid ID, and we'll send them back to the main menu. Okay. So now we have obviously a second ID. We've got an account that they're sending from, but we need to get the ID of an account they're sending to. And the simplest way to handle this is just to go back up to the top, right where we put the initial account ID, and we can do an account ID too. All right, we can do an account ID too, and we'll use this account ID to track a second account number. And really, we can use this exact same code. We've used this account ID thing so many times. It's almost like this should be a function, right? We probably could encapsulate this in a function and not have to type all this out every time. And that's another thing, when you're going over this code and you're saying, well, what can I do to kind of spread my wings a little bit? What can I add? What can I change? I'm trying to give you guys some little ideas for things that you can do that will improve this code that you can do after the lesson's over. So we're going to enter the account ID, and let's change this. Let's be more specific so that our users know what we're asking from them. We're going to sender ID, receiver ID. And we're just going to change the account ID to account ID 2. Do all the same stuff, but with account ID 2. Okay. And then this is going to be this is going to be the receiver ID. Okay. So now we've gotten and we've validated our account numbers. And if we've got invalid account numbers, we send them back to the main menu. Please try again. So the next thing we need to do is we want to get the amount of money that's going to be transferred between these accounts. This is something we've already done as well, right? We did this already. Right here. We can ask them for the withdraw amount. But in this case, we're not wanting the withdraw amount, are we? We're wanting the transfer amount. Okay. And we don't have to do any validation in main for the transfer amount because we validate transfer amounts inside our functions. Right? So the first thing we're going to do is we're going to withdraw the money and validate, which we've already done. We've done it right here. Okay. This is where we've withdrawn from an account previously. And we're going to be withdrawing from account ID, which is actually going to be the first account ID, the sender account ID. And if that's successful, we don't want to send a message that the withdrawal was successful, right? They're not trying to withdraw. They're trying to transfer. So we're going to say that the transfer is successful, but the transfer isn't successful just because this has happened. The other thing we need to do before we tell them the transfer is successful is we need to do an account deposit. And again, we don't need the if. We don't need the if because we know this will succeed because we've already checked this criteria. If you want to include the if, that's not a bad idea, and it's not a bad thing. because if those checks change in the future as you're toying with the code, it's already in place for you to be able to respond to that potential failure. Okay. And if the withdrawal fails for some reason, if F amount is negative, right now that's the only reason that it would fail, because that's the only check we have in place. And we want to just let the user know that the transfer failed. That the transfer failed. Okay. And we see that we have a missing semicolon here that we need. And let's go ahead and try to build our project. And we see that now our project builds just fine. Okay. And just because our code compiles, guys, it doesn't always mean that we have our code correct. It just means that there are certain errors the compiler is capable of checking for that we haven't made. So in this instance, if we look at accounts, at account deposit, we can see that we're actually withdrawing from an account and then depositing back into that account. So we need to put that 2 there to make sure that we're using the second account number that gets entered. Okay, so the last thing we need to do is we need to go ahead and test this. I'm sure you guys are capable of testing this already, but I'll kind of walk you through it. We're going to open new accounts. We'll say that one has $10,000, and we'll open another new account with $20,000. And then we can go right here to transfer. We'll send from account 1 to account 0. And we'll just make the accounts even. We'll send $5,000. And we should be able to print our account summary here and see that now we're able to transfer money between accounts. So that was our mini project, guys, and I hope that was a good learning experience for you to show you how some of these elements all come together and create code. And I hope it also shows you that if we take our code kind of piece by piece, kind of bit by bit, and solve the problems incrementally, we can solve fairly big problems without much complexity. For this project, we generated a little over 200, maybe 250. Yeah, about 260 lines of code in 2 different files. We've got a nice functional program in front of us that does something useful. Also with that, I want you guys to understand how these structures and these functions and putting together your code well helps you as the programs expand. As you move forward in your programming career, these 200-line programs are going to become 1,000 lines and 10,000 lines and 10,000 lines over 1,000 files. Programs that you use every day are large scale. The important thing is to get this part of it down and to learn how to break that code down to these small components. If you were a programmer right now and I was to ask you, hey, I've got a problem with the banking application. Whenever I deposit funds, the money doesn't go into the account. Looking at this code, you can kind of see, well, the first thing I would do is to go here and see what the deposit option is. And then I know there's this code and this code associated with that operation. Okay? So learning how to break these things up into smaller components, it's going to be key to your success. That's one of the first things you need to really learn outside of the basics of data types, variables, so on and so forth. The second thing you need to know is not just to be able to follow along with me in the tutorial. There are other things you can do. You can take this code that you've generated here and make improvements, right? What about overdraft protection? What about overdraft protection? Do we want to make a check here that says that if you try to withdraw more money than is in the account, that's going to cause an error? Or what else could we do? Maybe we could add a check that says if you draft more money out of the account than is actually there, I'm going to take that money out, and I'm also going to charge you a $35 fee. And that once your account goes to negative 200, now I'm not going to allow you to make withdrawals anymore. And that will constitute an error. There's a lot of functionality that you guys can go in and kind of add to this code. Right now, if you notice, if we go into our logger, which we haven't really looked at yet, if we go into our logger, it just prints a straight string. It prints a straight string, and the amounts are very long form. Could you go in here and alter these print statements so that it prints in a more presentable way? Maybe one print statement per line. As you're going through this code, start to make those changes and start to make those improvements. Add functionality, add other operations. What about accounts if they want to transfer some of their money into a stock and you have some interest, compounding interest that you apply to money in those accounts? All kinds of little projects like that can kind of get your mind working around this code and to get you from that beginner level to the intermediate level. There are all kinds of resources online that you can use for references so that you don't have to store everything in your memory. Because a lot of the syntax and things, it takes some getting used to. So make sure you're taking advantage of some of those online resources for reference materials. Kernighan and Ritchie's C programming language, which is available at Barnes and Noble and on Amazon. It's an amazing book on the C language that can help you get to that intermediate level, that next level in your programming career. Not only does the book have really great examples of C code, it also will provide you with some really fun programming assignments that help drive home some of these concepts. And my contact information, you can always contact me if you have questions about C or programming in general. I'm happy to help people and happy to respond to you guys. So that is it for the introduction to the C programming language. I hope you guys had a good time. I hope you learned a lot, and I look forward to seeing you in future tutorials and interacting with you guys as you keep going with your programming careers.